Hello, hello, Shagat the Unknown here. Welcome to another Rust coding stream here on the 2nd of November 2022, local time 1741. Now, last time we did a couple stretch goals, so we're going to briefly take a look at that. We're not going to spend a lot of time for reasons, but basically we implemented bloodstains, better walls, and a hunger clock. So you can see the hunger, well, it's already gone now. So we'll give it a moment. I'll start getting hungry. Here's some rations over here. This percent sign. We're gonna have a couple potions or so. Actually, we could just wait. I always forget about that. So we got some rations, and every 200 turns we'll go a bit hungrier. And at a point we'll start taking damage and we'll eventually die. So that's unfortunate if you let that happen. Now you see in the bottom right, we are hungry. And that's about it. Bloodstains, hunger clock, better walls. I feel like there's one more thing that I'm missing. What was it? Oh, particle effects. Yeah, we saw those come into play when I did a few things. So if we watch my @ sign there on the upper left, when I use the potion, we see that little heart. That's actually considered a particle effect in this case. And we have particle effects from things like the fireball scroll, as well as the, oh, we're starving now. Once 200 turns pass, we will start taking damage, unless I eat. It took forever to get out of this dungeon here. Here we go, bop. And if you were looking there at the combat, I meant to draw more attention to that, but if you take a look there at the combat, you see little signs popping up over our characters. Oh, I'm dying. So let's go ahead and eat some rations. We're well fed, so we actually get a power bonus while we're well fed. While we're well fed. Take a look at it. See, I just flashed with the exclamation marks. Now we're both flashing because we're both taking damage. Good stuff. Boom. And that's it. And now I can heal. You can't heal when you're like starving or whatever. At least not like that. You can use potions. But that's about it. So I don't want to waste any more time. Pretty late today. It is an office day. And I just slow. Once I got back home, I was just in slow motion, eating and everything. So let's try to get through these 3 sections today. That's my goal. The first 2 shouldn't be too bad. Traps will be a bit longer. So we'll take a look at what happens. I'm going to go ahead and... Actually, I'm interested that this is going to be a component. Just looking ahead, what's already on the screen. I was thinking... I was going to make a guess. This section is going to be called Magic Mapping, and it's about like a scroll that's going to reveal the whole map. And I thought we were... I mean, I assume this is still basically going to be what's happening, is that it's going to... like go to the map and literally just mark every tile as revealed. We'll see what actually happens, but that's my guess. Like that seems to be the simplest way to do it. We already have that construct in our map of whether a tile is revealed or not, so it seems like that's going to be all we have to do. Rex paint menu is going to get us a nicer looking main menu. If we take a look at it, it's going to be something like that. Pretty quick section. There's going to be a lot of print colored stuff that I don't like typing, but we'll get through it. We'll have a better menu, and then simple traps is going to be the longest section, and we'll see how it actually goes. Hopefully it's not too bad. Going to be a couple beefier things here with the systems, but we can get through it today, hopefully, and then that'll set me up next time for being ready to go into the maps. What I did not do, one last comment, is if I don't have to sneeze in a moment, one last comment, what I did not do is pull down a fresh copy of everything. I was just thinking about that before starting. And what I actually was thinking, though, is that it might be better to do that before going into maps. So let's get these last couple of things implemented. Then I might just pull down a fresh copy, exactly what's in the repo. That way... we're in one-to-one parity, so if I've made any slight, like, oh, there's a plus sign and it's supposed to be a minus sign or something, that and it's, you know, it might be good enough that it's not breaking anything now. I want to make sure that's all in complete parity. And sometimes that kind of thing happens when you're following a tutorial. You type the wrong thing or something, and it may not break something immediately, but I want to make sure that's not going to, you know, be a problem in the future. So I did mention before that was a problem where the diagonal movements were for the monsters and stuff. I forgot to do the +1s and -1s on those. So, you know, when I was playing one of the ones from the tutorial, the WebAssembly, like in the browser, I'm like, wait a minute, their monsters move differently than mine. Why? And because I'd always noticed that they don't move diagonally, but I was like, what's going on? Turns out, yeah, I missed some little signs there. And it happens, you know, when you're writing hundreds of lines of code, you're bound to like miss one thing like that. And you know, with the movement things, it's like, oh, this is just like cardinal directions, so I'll just copy them and just add the things that I need to, and then you miss something like that. So be careful with it, but that's why I'm probably going to pull down the exact copy after getting done with traps here, and the next time with generating maps, we'll make sure we're one-to-one identical with what they have at this point in the tutorial. All right, that's enough of me going on. I want to get started, because we got a lot to do. So let's get started on magic mapping. Really common item in roguelikes is the scroll of magic mapping. You read it and the dungeon is revealed. Fancier roguelikes have nice graphics for it. Graphics. In this chapter, we'll start by making it work and then make it pretty. So we're going to add a magic map component. Oh, we already have a particle system, so you know what we could do? For every tile that gets revealed, make a little like flashy thing. It could even be cool if you like made it a delayed thing where it goes in like rows or something. I don't know. You could do whatever. Adding a magic map component. We have everything we need except for an indicator that an item is a scroll, or any other item really, of magic mapping. So in components.rs, we'll add a component for it. It's a magic mapper. So we're going to have to do all the usual stuff by putting it in main. And do I need to pull it in from here? No, I don't. Okay. We're going to go ahead and register it even though I haven't added it yet. gs.ecs.register magic mapper. And then I'm going to open up components, and I already copied it. It's boilerplate. We just copy these now. We've gotten lazy with them. Now we need to go to the save load system. That's the other place that we need to make sure we account for that. Magic mapper. And then we're going to put them in the macro invocations here for saving and loading. So let's plop those in there. We're good. Next, we're going to need to add it to the loot tables. So this is probably another one. I'm going to say this is enough boilerplate at this point that I don't mind. Just it's a function that's almost identical. I'm going to justify it one time here, but I think I think it's pretty straightforward. So what we have here are a bunch of functions like rations, and it just says make an entity with the position, with renderable, with name, with blah, 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 blah. Well, here's our new function here. Why? Oh, magic. Oh, that's weird. Okay, let me show you real quick. I clicked this copy button here, copy to clipboard. You see it says copied? Well, when I pasted that, it gave it a main. So that was odd. See that it gave it a main and it stuck it in there. I understand why. The way these books work is you can theoretically run the code in there. So I guess I understand why it did that, but that was a bit unexpected. I was like, that's a lot more red than I should see. It should just be magic mapper. So anyway, back to my justification thing. As we see, we have rations, we have magic mapping scroll. They're basically the same thing, right? The only difference, we have position, we have renderable. The name is slightly different, scroll of magic mapping. It's an item. It doesn't provide food, but it has a magic mapper component, and it's consumable. That's it. I mean, it's basically the same thing. So then for our room table, we're going to do a .add magic mapping scroll 400 So what I would have done, even if I were typing that, is literally copy, and you've seen me do that even last session to make the rations. I would have copied rations and modified things, but I don't see a need to do that. So then we're also going to have to come up here, and we're gonna say magic map, magic mapping scroll, ECS X and Y. Beautiful. Let me make sure I didn't typo that down here. Okay, yeah, we're good. Sweet. So if we cargo run now, we can find them, we can pick them up, they won't do anything. So the glyph, it's another one of these parentheses, but it's cyan 3. It's a different kind of cyan. Interesting. Ready? Give me one moment here. I think that sneeze is finally ready. It's building. It's building. Oh my goodness, I feel like a new man. All right, let's continue on. So we're gonna mapping the level, the simple version. We'll modify inventory system.rs. Actually, one comment, 400. We made it dummy. Yeah, notice that we've given it away to 400. Absolutely ridiculous. We'll fix it later, but for now we really want to spawn the scroll so we can test it. Yeah, we made it like dummy thick. It's going to spawn. So we're going to modify inventory system to detect if you just used a mapping scroll and reveal the whole map. So if it's a magic mapper, there's going to be a whole new little section in there, very much the same as what we've been doing. This tells us multiple things. I'm going to go ahead and call this out because there's a point where hopefully we've learned how this stuff is working by now. So let's really like drill down what's going to happen. When we're saying magicmapper.get, that's going to be red. That's going to fail. That means the function, the system, is going to need access to the magic mapper components. And it's not actually mutating the magic mapper as far as I can tell. And I think this would actually be get mute as well if it were. So we only need read access. So it's going to be not read expect. Read expect is the resource, correct? I can't remember right now, but we'll see it in the system data thing. So we know what we need to pull in. We know what it needs to look like. I'm going to up the size one time here. Alrighty, hopefully that's a little bit better. Okay, so in the inventory system, this is not, we need inventory, item use. Item use, oh, this is it actually, right? Yeah, this is it. Item use system. So then we're going to need, storage. So it's going to be read storage, and it's a lifetime of A, and it is magic mapper. So then this is all going to get mad because types are wrong now. So it's going to be magic mapper. Yep, that's it. Okay. Now we're going to come down here, and I'm just going to slap it on near the end. And it's going to be similar to this. So if I want to be really lazy, I can copy this and see if I, screw up and forget to change something. It's actually, this is a little bit too much, but that's fine. We can work with it. If it is a magic mapper. Now, instead of item edible, we're going to say is mapper. We're going to say magic mapper.get, use item.item. That's the same. We're going to match on is mapper, none does nothing. Here, we're going to get rid of most of this. So where's the end of the sum? Right there. We don't care about the target and stuff. So this is all identical. So this gets us to where we need to be. Very quick to just make those little modifications there. And, that's something realistic you would do in your code anyway, probably. Copy a chunk and then modify it, if it's going to be that similar. All right, so now we're going to say for r in map.revealed tiles.iter mute, and then we're going to dereference r and then set it to true. Then we're going to say game log.entries.push. The map is revealed to you to string. And that's it. Cannot borrow data in dereference as mutable. Ooh, so the map is not currently mutable. Read. So where is la mapa? We're pulling it in up here. So instead of read expect, it's going to be write expect. And we're going to have another red, I imagine, because here this needs to be mute map. And there is no more red. Cargo build. Beautiful. Almost. There we go. Took a little bit. All right, so there are some framework changes also. Okay, no, this is just reading the tutorial. There are some framework changes also. See the source. But we've done this often enough. I don't think it needs repeating here again. If you cargo run the project now, find a scroll. They're everywhere and use it. The map is instantly revealed. Spoiler alert on the little animation there. Now, I find it interesting because I promise I did not read ahead and coordinate with the tutorial, but I started getting to the point as well where I said, let's just figure out what we need to add on our own. I started doing that last time, and that's right around the same time the tutorial has made that point as well. Like, hey, you know how to add it up here, just do it, right? If you really need to see the source, you can, but we know how to add Magic Mapper here and all that fun stuff, right? So I appreciate that. I started making that point as well. Ooh, we got something mad. Something is not happy. Magic Mapper from the world, but oh, I grabbed the wrong one, didn't I? A storage with read access. Hang on. Now that's interesting. As I was literally saying, like, this is easy. I had to have left off something obvious somewhere, yes. So in main, let me double check. We did register Magic Mapper. It is a component. Wait, is that it? Did I need to save main? Yeah, I didn't save main, which is there save all files. Okay, we should make sure. I was like, I did do everything I needed to do. You're getting me there. We didn't make sure it saves all files, or I save the file as I edit it. So, good, interesting little gotcha there. So let's go ahead and run the game now, and we should be able to launch in. If I can find the corner to drag the window. Alrighty, now we're good to go. Let's grab one of these and bop, there's the map. Now, very interesting. I don't know if this is what is going to be changed in the tutorial, but I actually really like seeing all the walls, but I don't know. It's a little bit much maybe, but I kind of like that. It's personal taste, I guess, at that point. Okay, that's it. It works. We're done. All right. Well, thank you for tuning into the stream. I'm joking. We're not done. There's still a lot more to go. All right. So now that it works, I told you that was very easy. And I guessed initially we already have the concept of a revealed tile. So it's probably going to be a matter of simply setting them to revealed, which is what we're doing. Very simple. So there are some framework changes. Yep. Now we're going to make it pretty. While the code presented here is effective, it isn't visually attractive. It's nice to include fluff in games and let the user be pleasantly surprised by the beauty of an ASCII terminal from time to time. So we'll start by modifying inventory system.rs again. So if it's a Magic Mapper, we're doing a slight little bit of stuff here with the new run state, Magic Map reveal, and then that's going to mean that we're going to be doing some extra goodness with a new run state. So again, we're going to make it look really cool, I guess. I don't want to scroll down too far and see a spoiler because if I have seen it, I don't know what it's going to look like yet. I don't remember. So I think it'll be cool to see. I assume we're going to use the particle system that we already developed. So I think it'll be cool to implement this, and maybe, I hope it won't be too much imagining. The code should speak for itself of what's actually going to be happening. So we're going to say used item is true, and the map is revealed to you. And we're going to kill this. Boom. Now we're going to say star run state equal run state magic map reveal row 0. Now it's I think this, I promise I did not read ahead, but I think this is going to be exactly what I said would be cool, is doing it row by row. The fact is we're setting row 0, so I think, yeah, this is what's going to happen. Again, the code should speak for itself. And here we go. So we're going to need the run state, which we don't have. And we're going to need to make a new magic map reveal. So we're going to import run state. We're going to say generate variant magic map reveal. That's made in here now. We're not using it, but it's made now. And now we don't actually have run state. So what are we going to do? Well, remember, that is a resource. So we're going to say run state. And then to make it happy, we're going to say read. No, it is not read. Excuse me, it's write. Write expect run state. Because we are modifying it. We're mutating it. So I was going to make this other comment about the map as well, that it won't need to be mutable anymore. So we can actually change this back to a read expect, because we're not changing it in here. So that's good. Cannot borrow run. Oh, I need to make it mutable in here. My bad. Boom. So now it be mutable. All right, and we are basically modifying the game's run state to say that we're currently where is it? To say that we're currently doing a magic map reveal. Alrighty, simple enough. So we're gonna have to go deal with that variant now in main. I was gonna make the comment about the map and say that we could probably change that, but I was maybe going to not do it. Since I'm planning on pulling down a fresh clone of everything after this, it would keep it in parity, but let's not be too lazy about things. If we see something that's obviously a problem, problem is subjective, but if something is mutable and it doesn't need to be in Rust, I think we should almost treat that as a problem. It's good practice, because the language gives us these constructs and we should take advantage of them. So this is fine. So we've added magic map reveal. Now I want to see what it defaulted to. It shouldn't matter too much, but okay, I32, beautiful. The tutorial shows I32 as the type for the magic map reveal, but I want to again make sure we're in parity. So let's go. You can tell I like that word. Magic map reveal, and we're just going to grab the row. We're not going to match on it. So we're going to grab the row. That way we can access it down in here. And we're going to say let mute map equals self.ecs.fetch mute. And it's going to be map for x and 0 map width. Let index equal map xy index. And I think we're going to say, yeah, we're going to fix, so X as I32, and then Y is going to be row. So there's an interesting thing. Sometimes, maybe I'm weird, but sometimes X and Y get a little confusing in arrays for me. Like, I understand how to traverse arrays, but X, the weird thing is when you think about rows versus columns and all that, I guess, X you usually think of as this, like, X is actually traversing the columns, right? But you typically associate columns with like this vertical thing, which vertical typically means a y value. But X is actually traversing the columns because it's moving horizontally. So there's some weirdness. Like in my brain, row and X are both horizontal things, but you kind of have to swap them around a little. Probably just making it more confusing than it needs to be, but my brain does that. And I was going to say, this might seem weird, and it's probably just me. All right, map.revealed tiles. But what I was going to say is we're going to fix the Y value, and then we're going to be like updating that row over and over. So I guess we're going to do it with the run state. Yeah, we're going to do it with the run state. So we'll get to that in a moment. So map.revealed tiles, IDX, equal true. This is a very interesting way to do a loop as well, but I understand why. If row as usize equal map height -1, new run state equal run state monster turn, else new run state equal, fix that, run state magic map reveal, and it's going to be row +1. So it's a very interesting way to do a loop because we're actually doing a double for loop, but it's kind of a hidden double for loop, right? Because we're setting a new magic map reveal, so we're going to do another for loop after the fact. So yeah, the tutorial here says it's pretty straightforward. It reveals the tiles on the current. Oh, damn it! I wasn't going to scroll down. We already know how it's going to work anyway. It reveals the tiles on the current row, and if we haven't hit the bottom of the map, it adds to row. If we have hit the bottom of the map, then it returns to where we were. Monster turn. If you had cargo run now, find a magic mapping scroll and use it. The map fades in nicely. So now this is critical, by the way. I want to draw attention to something behavior-wise. Run state is essentially a very beefy state machine at this point, if you want to think of it that way. So what we generally know is that if we use an item, if we attack, anything like that, that is like taking the player's turn, and then after the fact we go to the monster turn. But I want to be like, I almost want to just verify a couple of things. So yeah, player turn, after the player turn, we run systems and we maintain, then we do monster turn. So I wonder, would there be a problem with actually transitioning to player turn instead of monster turn? Because the only time like the player does things really is when we're awaiting input. The point I was going to make, and this is actually getting to that point, is that it's confusing to maintain this big state machine, and there are some potential issues where if we decide we want to add a new state that can kind of take place in between there or something, we need to make sure every possible transition that could be affected by it is accounted for. So this means that if we add that new state, what if when we're done revealing the map, it no longer needs to be monster turn, but it needs to be that new state? There would be multiple places that we would have to make that change. So that can be a potential pitfall if you're managing kind of a state machine like this, but there aren't a lot of ways around it. It's the fact that there are multiple transitions from each state that make it really difficult to maintain. But again, it is a potential pitfall. It is something to be wary of. That's all. There are so many different places that the run state is being modified at this point that it can be hard to track. You almost want a graph, like a state machine graph or something, to keep track of it if you're getting much more complicated. But, you know, we'll manage. Okay, let's try it. Cargo run. I've already seen what it looks like. We kind of guessed what it looks like. I promise I didn't read ahead, but I guessed how we were going to implement it, which isn't that hard, and then the way to make it look nicer. Map is revealed to you. I broke something. You know what I probably did? Did I... Hold on. What did I do? We get a mutable reference to map. For X and 0 to map width. We let index be X is I32 and row. Map.revealed tiles IDX equal true. If row is usize, equal map height minus 1. New run state monster turn. Otherwise, new run state, magic map reveal, row plus 1. Now this I'm really interested in. What did I miss? Let's double check the inventory system. Run state magic map reveal. This seems fine to me. Used item equal true. Game log entries, the map is revealed to you. Run state equal run state magic map reveal. Ah, I missed something in the player turn, didn't I? Okay, my bad. I scrolled right past something. Run state, player turn. So what are we doing here? Systems, maintain. This is why the state machine threw me off for a minute. And I was just very interesting. I was talking about it as I made a mistake here. So that's good. We caught it. So we're going to match star self.ecs.fetch run state. All right, and what are we going to do here? Run state. Magic map reveal. And we don't care about this, so we're going to say dot. And it's going to be new run state equal run state magic map reveal row 0. Oops. New run state equal run state monster turn. There we go. That's the trick. Okay. Yeah, so what was happening is player turn. When we use the item, we were taking a player turn. And this is why I said it actually gets really weird. And there's some issues with maintaining a state machine like this. So we use the item, which makes us take a player turn. Right? Inventory system. Let's see. No. Okay. You see, it's even weirder than that. So, awaiting input, we take player input. The player input is where we make the intent to use the item. Then we go to player turn, right? And we run systems and do a maintain. This is where the item actually gets used when the systems are ran. Then we've now put it into the magic map reveal state. But what was happening here is we were immediately transitioning it to monster turn. This is why we didn't transition to player turn, because we actually needed to take care of this here as part of the player turn. So we could have much more complex logic going on here, this like secondary match. There could be other special things like this that may end up happening. That's interesting. Again, the place that Magic Map Reveal is set is in the systems because it's part of the item use system. But then we immediately, just like this here, it was run systems, maintain, and then set the state. So we never actually processed that state. So by doing that, now we're kind of just hard coding this state, which is maybe a little bit of an odd way to do it. There might be a cleaner way to do that. But you know, it's here. It is what it is. We're basically setting this state as the same thing that we set it in the item use system. Item use system. And then any other time we do this, if it's not a Magic Map Reveal, then we just go to the monster turn. And that's why from the Magic Map Reveal, we transition to the monster turn, because that's where that would have normally taken us. All right. Very, very interesting. Very odd way for the behavior to kind of be hidden a little bit, and not the easiest thing to maintain. That's why I spent so much extra time, breaking it down. Okay, come on, spawn an item. And this is where we find out we broke the spawner code. Now, the first floor is kind of goofy. Alrighty. Boom! Okay, I like it. I think it'd be cool to do, I mean, this will be up to you as a, as the developer or whatever, but I think it'd be cool to also, we already have an index and stuff here. So we would do the particle system and then slap in some, I don't know, slap in some kind of shiny, like a star or something for each tile that's being revealed. That could be cool. Like what you could do is check if the tile's revealed and only put that star there if it wasn't already revealed. We'll set that as a personal stretch goal. We can add that if I finish these with enough extra time. If we finish the trap section, then I'll go ahead and do that as a little personal stretch goal, because it shouldn't take long. It shouldn't be difficult. But I don't want to waste time on that right now. So then the tutorial says, remember to lower the spawn priority. In spawner.rs, we're currently spawning them everywhere. It's probably not what we want, so we'll edit it to have a much lower priority of 2. All right. And then the tutorial is done with this section. That was a relatively quick chapter, but we now have another staple of the roguelike genre, magic mapping. All right, Rex Paint menu. So keep moving on. Rex Paint. Grid Sage Games, the amazing Reddit user, Kaisrati, provides a lovely tool for the code page 437 image editing called Rex Paint. RLTK has built-in support for using the output from this editor, as they used to say on the BBC's old kids shows, Blue Peter. Here's one I made earlier. Okay. This looks pretty cool. So this is using ASCII characters, right? Because it's code page 437. So it's just built. It's like a painting tool with ASCII. That's nice. I cheated a bit. I found a CCO image, resized it to 80 by 50 in GIMP, and used a tool I wrote years ago to convert the ping to a Rex Paint file. Still, I like the result. You can find the Rex Paint file in the resources folder. So loading Rex assets. I'll go download that in a minute. Actually, no, we got to do it now. Let me just switch over to the code real quick, and let me go to the source code for the chapter. I know you don't see this right now, but bear with me. Resources. Where are resources? Boom. What is it called? Small Dungeon 80 by 50. Download. And I'm going to, let's see. I'm going to save it directly in the repo here that we're working with in the resources folder. Small dungeon 80 by 50. You should see it pop up. No, I don't have resources open, so you can't. Let's go over to VS Code real quick. Make sure it went where I expected it to. Small dungeon 80 by 50. Open anyway. Text editor. Oh my god, it's a beautiful image. Wow. Alrighty. No, jokes aside, let's actually get to the implementation here of using it. So loading Rex assets, we're going to introduce a new file, rexassets.rs, to store our Rex sprites. And it's going to look like this. All right, so let's head over there and make that. What I would like to actually see is some extra management in splitting up like systems into their own module. So what I mean by this is each system is a module, but you could have a module called systems, and then every module would be in that module. And what you could do is in source, you could have another folder called systems, and like split that apart, so it's maybe a little easier to find what you're looking for. That's not going to be a big deal right now. Maybe we'll do that at some point. I don't know how we're going to do the map stuff, because we're doing a lot of map algorithms. I think we are going to do a refactor. We skimmed the map stuff last time, and I think it did say there's going to be a refactor. Alrighty, what's this called? Rexassets.rs. I can't help but think of Metal Gear Rex. You know, that's just how it is, right? It's just how it is.
Metal Gear.
Use RLTK Rex XP file. Okay, it's happy. RLTK embed. Ah, I know why, because we're not using this anywhere. Embedded resource. Let me pull this into main. We're gonna say mod rex assets, and now we're mad in here. So embedded resource, boom. Small dungeon. So that's the name of the resource, I guess. And it's going to be /resources. Small dungeon 80, excuse me, 80 by 50. Now, is it going to be, okay, it is mad, yeah. I was going to say, I don't know if I need to do /. They do have two, but I thought we're in source. We're going to go up one and then into resources, but no. Did I misspell something? Let's do this again. Or let's actually try resources, and then let me copy the name, rename, boom, like that. So source resources, so it should be source .. Why not? We're in source, we need to go up one directory. Not two. Cannot find the path specified. I want to see how this macro is implemented real quick. Include, okay, I want to see how it won't let me. I want to see how include bytes and include string and all that stuff work. File. So you can actually do a file. Oh no, it's an expression. I'm sorry, I always look at the wrong one. It's an expression. But what I find interesting is when you use these macros, they actually tell you at compile time whether the file even exists or not. And I'm curious how that's being done. I'll look into this more later, but I'm curious about it. I'm also curious why this is not being found. I see why. I misspelled this a long time ago. Resources. There we are. So again, the tutorial does show double like dot dot slash dot dot slash, but their directory is a bit different than mine. That's why I initially wrote it like this, and that was correct. It's all on your directory structure. So there we go. Hopefully nothing else is mad, but oops. Oops. We're good, right? We're all good. Okay. So now we're going to do pub struct rex assets pub menu xp file. And then we're going to do an impl rex assets. So it sounds like we're going to just cram them all into one struct here. Allow clippy new without default pub function new, and it's going to return rex assets, of course. You could do capital self there as well. I usually like to explicitly type it, but it is what it is. There's a benefit, I think, to doing capital self. Watch it not work this one time. There's a benefit to doing that. Yeah, I know. You're mad because I'm not returning anything yet. RLTK, we'll talk about it in a moment. We're going to do a link resource, and it's going to be small dungeon / resources small dungeon 80 by 50 dot xp. If I can type. And we're actually going to need this one more time, so I'm going to copy the string. Okay, so we're going to do that link resource, and then we're going to do rex assets menu xp file from resource, and it's going to be that dot unwrap. And I think we are good to go, except I missed that. Whoops. I noticed it was red a minute ago, but I didn't really pay much mind to it. So there's a slight advantage to using self here, is that if we rename rex assets, there are fewer places that we have to change. I think we can even do self there, can't we? Yeah, so you can actually put self all throughout this code here once you're in the impl block. Capital self, capital S. So it prevents you from having to, like, you know, rename that. Like, what if you change it from rex assets to something else? It prevents you from having to change it in as many places. However, in a modern IDE, in Visual Studio Code, I can press F2 and say it's now called donkey, and it changes it everywhere anyway. So it's not a big deal either way. There may be other reasons that you would want to call it self in the impl block, but that's the first thing that comes to my mind, the first benefit. So embedded resource slaps that somewhere. I don't exactly know. It's just slapping it somewhere in the code, like in the, not the code, in the binary. I don't really know where it is. I don't know what's happening with it. We don't have a lot of info here. Resource name, it just doesn't include bytes as a resource name. I have no idea where that goes. Yeah, I'm not sure. Oh, no, I'm stupid. It's a macro, so it generates code, right? So we're making a const, which is a like a global, kind of like a global, right? Const map height, right? U16 equal 1, 2, 2, 3, whatever, right? This is what we're building. We're making something here. We're making that const, like static, basically, almost. Link resource. Now, the reason I'm interested or curious about link resource is that we still need the same, we need the file name again. And we need the file name here. I'm wondering why we aren't able to use the small dungeon name each time. I mean, we use it on link resource. So let's take a look at link resource. It does an RLTK embed. It locks, which might mean that it's something like a mutex, or I don't think it is a mutex, right? But something like a mutex. I'm not sure what it's locking, how it's locking. So we'll take a look at RLTK embed. But then it's adding the resource with the file name and the resource name. So let's take a look at that in here. RLTK embed. It's a private field. It is a mutex. Okay. Well, what I'm interested in is that you just immediately... I thought you had to unwrap. If you locked a mutex, I thought you had to unwrap or something. I don't know. Maybe you don't. But it is a mutex. So... Oh, you know why? It's this parking lot mutex. It's not the standard... yeah. It's not the standard mutex. That's why. The library provides implementations of mutex, read, write, lock, conditional variable, convar, and once that are smaller, faster, and more flexible than those in the Rust standard library. It also provides a reentrant mutex type. Okay, so this answers the question of why it felt different. The reason I initially said it's like a mutex because I expected an unwrap to be there. So it is a mutex that holds all the resources, it seems. Actually, let me go back one more time. Embed, what is dictionary? It comes from bracket terminal? No, okay. Bracket terminal is the... Yeah, that's part of our... That's part of RLTK, I think. Yeah, I know it is. So then dictionary is just a hash map of a string, which is our resource name, and these static lifetime bytes, this byte array, basically. Okay, makes sense. So we're doing that embed, we're adding that resource to it. And then I'm curious why from resource needs a path rather than... And in this case, even, add resource. Might have to break it down a little bit more again, actually. Add resource. Okay. Self.entries.insert. That's all it is. It's just inserting into a map. So it's not doing much. It's just kind of all behind a bit of an API here. Because we don't have direct access, do we? Right. This is static, lazy static, embed. And are we actually using embed in here? Oh, no. Okay. Because embed is this mutex dictionary, anywhere we use that, we get this API exposed. So once we lock the mutex, we get this add resource and get resource and everything. Okay. I got it. And again, we're getting this XP file structure representing a RexPaint image file, which is a stack of layers. Okay. I'm just curious why we do from resource with a path rather than the name of the resource. That's the only one I'm kind of unsure about. Get resource. Let's take one more look at it. Let fixed path is... Okay. If the main separate... Okay, if the separator of the path is not that slash, what is that, /? Yeah, I think /. If it's not a /, then replace them with a /. So they're normalizing it. And then otherwise we just keep the path as is. Sometimes you might have like On Windows, you might have double backslashes for each one. So this normalizing it, right? And then self.entries dot contains key. Is it the path to the name? It's okay, hang on. Add resource. It is just the path. Then okay, I need to go back one more time then. What was the point of the name small dungeon and that stuff? Resource name ident. It's actually, oh, that resource name is what we have here. So then I can access it if I want by saying, right? Can I say small? Yeah, small dungeon is a thing I have in here. Okay. It's exposing that resource to my code. So it's basically what I'm naming the variable. Got it. Right. That was a huge, like, aside, and I apologize if that took a long time, if that was frustrating or like I'm sitting here, I want to finish all this, and then I take that huge aside, but I really want to understand how this is working. We have a lot of macros going on. We have this kind of magic API here, and I guess they're about to explain it. I'm looking here now. Very simple. It defines, that's fine. I want to understand the code. I'm going to understand it more by looking at this, at what we just saw. Like, I'm going to get a better understanding from that than reading a quick little description. So now that we've done this, we get to get a nice description as well. Not that I'm saying they did a bad job, but this really delving into the code, like getting into the meat and potatoes, if you will, that's where you learn a lot. If you're capable of, I don't want to say that in a patronizing way. Let me rephrase that. As a programmer, you should learn. That is one of the most critical things you can learn. And as a good programmer, you will learn how to be able to like delve into code and everything. And that's a big part of if you're working as a software engineer or something. You have to be able to like go look at code and figure out what's happening here. Why is it breaking? Or what do I do to add this new functionality? So that's kind of exercising that muscle there. That's what we just did, right? We looked at, okay, what are these macros? How do they work? What are they creating? What are they doing, etc. Getting a feel for that is like very, very practical skill in the field. So I like doing that a little bit before going and just being, oh, this is how it works, you know. But then we can use that to help kind of drill in what we just examined there, if that makes sense. But yeah, I don't want to be patronizing about it. Like, if you're capable of doing this, no. What I mean when I say that, what I mean is that if you're a newer programmer, you may not yet be fully capable of going into like a big code base or something. And it's like a muscle. Like, you got to do it. You got to work with it. So it is a thing that you learn over time. You get better at over time. That's what I mean when I say that. I'm not trying to be like, if you're capable, like pinky out, you know, like all hoity-toity. That's not what I mean by that. So let's go ahead and snip that one in the bud. Alrighty. This is it. So let's actually, since that was such a big aside, let's break down what we're doing. We're making a resource here called Small Dungeon. It's to that file that we have. We're linking the resource, which is actually what's adding it to the oh, come on. It's actually what's adding it to the map, to the hash map, to the dictionary thing, right? And then we're actually getting this Rex assets thing, which is what we're going to have access to throughout our code. And that's actually where we're going to have the file, or where we're going to have the XP file, right? Like the data itself. So this is all we're really doing, is a quick impl to get a new Rex assets, which has menu. And thus we could also put more Rex assets in here if we want, like a game over screen or something. So what are we going to do? Go to main or something? Probably, yeah, we're going to go to main. We'll look at that in a minute. We got a lot to read here, so let's take a quick step over here. So very simple. It defines a structure and loads the dungeon graphic into it when new is called. We'll also insert it into specs as a resource so we can access our sprites anywhere. There are some new concepts here. We're using RLTK embed resource to include the file in our binary. This gets around having to ship the binary with your executable. And makes life easier in Wasm land. I think by that it should be not ship the binary, but ship the file, right? And this gives me a good idea for a program I've been working on. I could use include string or something for a program I've been working on, and I'll get the same behavior in WebAssembly as on the desktop. Cool, I'm going to take a note of, I didn't think about that, because that actually bakes it into binary at compile time. That's good to know. What's going on, Jaeger? So then we're going to allow clippy new without default, tells a linter to stop telling me to write a default implementation when we don't need one. RLTK link resource is the second half of the embedded resource. The first stores it in memory. This one tells RLTK where to find it. And then menu XP file from resource loads the RexPaint file from memory. Alrighty, so in main.rs, we're going to insert this resource. And then we're going to open up GUI.rs, and we're actually going to basically display it. So let's take a look at that. Let's not scroll down anymore and spoil it any more than we already have. So where are my resources at in main? We can just plop it wherever, right? It's going to be Rex assets, new. Alrighty, now in GUI.rs, where's this going to be? Just before, yeah, in main menu. Main menu, we'll add 2 lines before we start printing menu content. Save exists and run state, let assets equal, then we're going to fetch this. Let's get that pulled in. And then context.render XP sprite and assets.menu 0 0 boom. And if I did everything right, did I save where I needed to save? Yeah, we got a menu now. It's looking pretty baller. Love it. Those vertical lines there look goofy. And notice those came in. See, it's changing where they're at as I do this, as I resize. That's because I'm probably not resizing pixel perfect. There we go. So basically, I need an exact multiple of the image probably for it to not have those lines. As I'm resizing it, as I'm dragging the window so I can see it with my old man eyes. It was a little off, but that's not actually part of the image. It's fine. So here we are. We have a thing. We have a menu, and it looks way better than it used to look. I like it. Now we can go back to the game and all that. Boom. Cool. No XP files. No marketplace thing. Alrighty. Let's take a look back over here. Actually, one moment before I do that. Let me drag it over. Well, I'll show why. Because if I drag it over when you're actually seeing the browser, that's what it does. Alrighty. We did that, so we put it in GUI.rs. Literally, context render XP sprite, that's built into RLTK. We don't have to do that. That'd be fun to explore, but that's more like building a terminal itself. Building like the terminal, the renderer, everything. That's more in that side of things. It's not really the game side of things. So it's not really worth exploring in this tutorial, but it could be fun to look at. Improving the look of the menu, adding a box and borders. Ooh, it's getting nice. To make it look a little snazzier, we'll work on spacing and add a box for the menu and text. Replace the current title rendering code with... Get a bunch of these. Do I need to type them? Do I need to do it? Do I really need to? Rust roguelike tutorial. So let's see. We're gonna draw box double, which I'm guessing based on the image that we could see, that means like a double line as the border. So draw box double with double line characters, exactly. Draw box double. It's gonna be 24, 18, 31, 10, RGB named, RLTK wheat. Okay. RGB named, RLTK black. Background is black, the foreground is wheat. And then in that box, we want to draw a few things. Oh, this isn't going to be too bad. So for the Rust roguelike tutorial, we're going to be on 20. It's going to be yellow and black. The others are going to be slightly different colors. So we're going to copy this and just modify them. It's not going to be too bad. 21, 9 plus 10 actually. Cyan and black and gray and black. And then this is going to be, I'm going to put my name. The tutorial is not by me, but I'm the one doing this, so I'm going to put my name. And use up, down arrow keys and enter. So we're going to say use up / down arrows and enter. There we are. And it's going to be 20, 21, 22. Don't want to miss that. We're going to be drawing over. And now, shouldn't have to change anything else. Yeah, there we go. Looks great, doesn't it? Doesn't it? We didn't have to change any of these. The positions were already nice and in place. This is the same primer I give every time we do UI stuff. Trial and error. How do we know these numbers? How do we know? Well, some of it makes sense in that we start the box at 18. You probably don't want it on the border of the box, so you'll bring it in at least 1 to 19, but in this case we're doing 20, so we're giving it one space between the border and where the actual text starts. So you could kind of infer that a little bit, like if you mock it up, you know, you say, well, I do want a little bit of a space there, right? So that's how you might come across that. But you might have tried 19. And if we try 19, we're going to be like, ooh, that's too close. Maybe. I mean, it doesn't look horrible, right? You could even argue in this case that it might be better because there's that gap between the title and then like the credits and the directions. There's, I don't know, like it's whatever, right? You could design it how you want. But the point is, you can infer a little bit from where the box is drawn and how tall the box is. So the box is 10. So you would assume that everything has to fit between 18 and 28, or between 18 and 28, because that's your height. Like you don't want to draw things out of the box. So 20, 21, 22, that's all good. These are on 24, 25, 26. Everything fits where it's supposed to. That's all, the whole point I'm trying to get across. When you're designing UI, there's some trial and error, but there's also some logic to it, right? And that's what we're seeing in this case. Trying to break down, because again, what I normally say is put values in and just try it. And it's like, well, I don't like that. It's too skinny. It's too tall. It's too this, it's too that. I don't like that color. Like whatever, you trial and error. UI is a hard thing, right? So anyway, now it says, fixing the spacing. Okay. You'll notice that if you don't have a saved game to load, there's an annoying gap between menu items. This is an easy fix by keeping track of the Y position we have used while we render the menu. Here's the new menu rendering code. And by the way, the example here, I do have a saved game, so you're seeing that load option, but what we're seeing here is that gap there in the picture. That's the idea. So yeah, we're gonna keep track of the Y position, and then we're just going to use that Y position. So basically, if we do draw something, we increment Y. If we don't draw something, we don't. All right. So let's see. Right before, yeah. let mut y equal 24. That's our starting position. So then we're going to say if let run state main menu, blah, blah, blah. If selection equal main menu selection new game, we print and we just use y on both of these. And then we do y plus equal 1. It should be right before, yeah, if save exists, y plus equal 1. And then if save exists, well, first we'll use y here. And then if save exists, we'll do y plus equal, oops. Uh-oh. There we go. Y plus equal 1. Beautiful. And then down here, we'll also use y. And that should be it. We shouldn't have to change anything else. So put y there. Now, everything should look identical for me because I have a save file. So see, everything does look identical. We're going to delete the save game. No, yeah, there's no gap between the two. If I load the game, pop out, now we have, or no, if I start a game, then pop out, boom. All right, we're good. Cargo run, it looks much better. The source code can be found, blah, blah, blah. All right, that's it. Oops, I did the thing I didn't want to do. All right, we're good. Cool. Next up, last for today, we're about an hour and 10 minutes in. Some big asides that I took there earlier, but it was worth it. It was, I wanted to understand what was happening. But I think the main menu stuff was pretty self-explanatory. Not actually that much going on, but interesting to see how those macros and stuff were going to work. Again, I'm really intrigued by the idea of including the, you know what must happen? No, I'll look into it later, but I'm still intrigued by the idea. Basically, I have this project I've been working on for the purpose of WebAssembly. Because I can't pull a file from the drive, I like hard coded in all the generation of the stuff that I wanted. And it's not really like, it's never going to change, but I do prefer the idea of pulling it in from the disk. And the fact that I can do that at compile time, basically include string, that actually makes me pretty happy. I'd rather do that than hard code in the data because it works fine on locally. That was only really a workaround for WebAssembly because WebAssembly doesn't have access to your disk. So I'm basically going to keep the same functionality. I can load in a file, I can use Serde to deserialize it and get the same data just like I would normally. In fact, rather than doing the file access the way I do normally, I mean, I could just do include string for both running natively and in WebAssembly. Yeah, that could be fun. Ooh, actually, no, there's still a catch. Ooh, there is a catch. In WebAssembly, okay, I know this is unrelated to this, but in my project, the catch is I actually read the file locations in from a config file. And it assumes some specific things about that about the locations of those where, yeah, okay. I'm getting on a tangent, whatever. Reading in from the config file makes it difficult because I can't just do include string on that. So I'll still have to have some slight variance between, but I can make it much nicer. That's the point. Okay, enough of that. We're sidetracked. Simple traps. Should get through this, and then I might do that little stretch goal I set for myself. So most roguelikes, like their D&D precursors, feature traps in the dungeon. Walk down an innocent-looking hallway, and oops, an arrow flies out and hits you in the knee. And then you're no longer an adventurer. This chapter will implement some simple traps and then examine some of the game implications they bring. What is a trap? Most traps follow the pattern of you might see the trap or you might not. You enter the tile anyway, the trap goes off and something happens. Damage, teleport, etc. So traps can be logically divided into 3 sections. An appearance, which we already support, which may or may not be discovered, which we don't support yet. A trigger, if you enter the trap's tile, something happens. And an effect, which we've touched on with magic items. Let's work our way through getting components into place for these in turn. So we're going to render a basic bear trap. A lot of roguelikes use the carrot for a trap, so we'll do the same. We have all the components required to render a basic object, so we'll make a new spawning function in spawner.rs. It's pretty much the minimum to put a glyph on the map. Oh, we're not going to make it spawn with like 400 this time? Damn. So I'm going to copy the bear trap function. Same justification as earlier. It's not really, it's boilerplate. It's nothing new at this point. So let's get into our spawn. It saves us time too. Let's get into our spawner here. Boom. No new components. Position, renderable, carrot, red, black, bear trap, serialize me. Add, and this is going to be bear trap 2. And up here, we're going to match on bear trap. Bear trap. Nothing else changes there. Really easy. We're spawning it now. If we cargo run, we'll occasionally run into a red carrot and it'll be labeled bear trap on the mouse over. Not massively exciting, but a good start. It's gonna be a pain to find right now, isn't it? Watch me find one immediately. I should add like a god mode or something. Just for exploration. So I can do that and like hold the button and just like find it. Find whatever I'm looking for immediately. I don't think we're gonna find one. Not that easily. By the way, I feel like I need to mention this because if you're watching a roguelike tutorial such as this, you may be slightly interested in roguelikes. And something in particular happened yesterday. An announcement that I'm really excited about. Dwarf Fortress, which has been since 2019 in like this kind of development mode to get ready for a Steam release with like official graphics and everything now. Yesterday, the 1st of November, announced that it would be releasing on the 6th of December. So just about a month away, and I am extraordinarily excited for that. To the point I'm probably going to take off work for that day. Because Dwarf Fortress is one of my favorite games, period. Easy, no question. And I've been waiting on that for a long time. I love Dwarf Fortress. I always play in ASCII mode, but I'm really excited for official graphics. It should be a good time. Oh, there's the stairs. So, really, really good news. And this will be out on YouTube before that releases. I know there are people who watch these on YouTube. Oh, there was a thing on the stairs. Interesting. Yeah, I know there are people who... that's probably why I didn't see it. See the stairs earlier. But yeah, I know there are people who watch these on YouTube. So if you're seeing this on YouTube and you're interested in that, well, there's your knowledge. There's your knowledge dump of the day. And hopefully you would be excited to give that a try, because I'm ready for it. We want to talk about so what I will say this. I don't want to get off on too much of a tangent because I want to keep progressing on this. But the one comment I want to make is I've been loosely following all the dev stuff for, the past few years. And one thing I noticed is that they don't really talk much about the adventure mode. They talk mostly about fortress mode. I'm assuming adventure mode is still supported. All the graphics are still going to be valid, like all the sprites that are added to the game they're going to be the same thing, whether you're in adventure or fortress mode. So I don't see any reason why it wouldn't support adventure mode, but I don't know what kind of overhauls they may or may not have done for adventure mode with like the UI and everything. That maybe they primarily focus on Fortress mode, or maybe adventure mode got some good love too, and I just never noticed updates about it. Just thought, I was curious about it. We still have not seen a bear trap. I have not seen a red carrot yet. We're like invincible now, except for hunger. So that's cool. Yep, nothing. What I probably should do is just up the spawn chance on them. Yeah, we'll do that in a bit when we're ready to spawn or to test them. But for now, I think we're fine. All right, let's quit. Fun little aside there about Dwarf Fortress for whatever reason. So, yeah, the tutorial says, not massively exciting, but a good start. Note that for testing, we'll up the spawn frequency from 2 to 100, so they actually already did it. I wish I would have read that. Lots of traps. Makes debugging easier. Remember to lower it later. Yeah, of course. If I load, this affects our spawning. Now I can't see anything, though. I'm not gonna... H... Just want to make sure I don't starve to death. God, how did I ever play like this? There's bear traps. Yeah, so if we look at it, yeah, it says bear trap. I can barely see it. I didn't expand the game this time. Okay, so there we are. Now, back to this, but you don't always spot the trap. It's pretty easy if you can always know that a trap awaits you, so we want to make traps hidden by default and come up with a way to sometimes locate traps when you're near them. Like most things in an ECS-driven world, analyzing the text gives a great clue as to what components you need. In this case, we need to go into components.rs and create a new component, hidden. I'm going to go ahead and do that. No need to go over to VS Code to copy that. Actually, yeah, we'll go over because I'm going to go ahead and do the register and all that. Hidden. Boom. And save load. That one makes sense. You're going to want to make sure that stays... we can't do that in the macro. You can't do trailing commas in macros because of the way they process input. Macros are the, one exception. Alrighty, save load. It's in main. It's registered. All the good stuff. Alrighty. Let's make sure I saved main so we don't have that problem we had earlier. So now we'll also give it to the bear trap. So our function here, it's probably going to be the last one. With hidden. Boom. And it takes no data, so we're good. All right. Nothing else changes there, so now we want to modify the object renderer to not show things that are hidden. Specs book provides a great clue as to how to exclude a component from a join, so we do that in main. Okay. So, is there a link to a specific... Okay, there is. Let's take a look at it real quick. Let's learn. So yeah, it says we want to modify the object renderer to not show things that are hidden. And it links to join here in the specs book. We have optional components. So we've been joining on things that we want. And now we're saying, I want this, 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 and that, but not this. That's what we want to do. So optional components, excluding components. For entity position, velocity, and then tuple. Not frozen storage. Interesting. If you want to filter your selection by excluding all entities with a certain component type, you can use the not operator on the respective component storage. Its return value is a unit tuple. Or a unit type, not unit tuple. But that empty tuple is called the unit type. So, cool. Alrighty, so that's what we're going to do here. Specs book is nice. Taking a quick look at that. It has a lot of good info in there. Just that page alone on joining components. We got parallel join and stuff as well. Alrighty. Oh, good neck pops there. All right. Let's get to doing this. So where are we rendering? Render. Let's look for render. Draw map. Let mute data. Positions, renderables. Yeah, that's it, right? Yeah. Not and hidden. Join. Collect. So hidden is not being added yet. So we're going to say let hidden equal self.ecs.read storage hidden, like that. That should make it happy. And then we need in our loop where we're destructuring, where is it at? There it is. For position render hidden. So we're going to say it like that. That way we know what it is that we're hiding. Okay. That should basically do it. But index, map XY, mapped up visible tiles, like should be fine. We shouldn't have to change anything because we've excluded everything that's hidden already. So if we cargo run, the bear traps are no longer visible. However, they show up in tooltips, which may be perhaps as well. We know they are there. Okay, I'm gonna pull the tutorial. That's odd phrasing. If you cargo run the project now, the bear traps are no longer visible. However, they show up in tooltips, which may be perhaps as well. We know they are there. Okay, I'm not sure. Strange phrasing. Let's run the game, and if we try to load, we'll probably crash. Yeah, we'll crash. And the question is, do you know why we crashed? I do. That's why I called it out before we crashed. It's because... It's gonna delay for a moment. Oh, I need to actually find one now. Oh, there's one. Oh, no, that was a player I looked at. Oh, no, there. Okay, bear trap. Cool. So it is hidden, but we can see it by looking at the tile. Interesting. Could almost be a mechanic. Okay. The reason is because our save load system did not have the hidden component in it when we last saved the game. So now that it is in save load, when we tried to load that file, there is no hidden component where it expects to find it, and it's freaking out. It's not happy. That's why. Okay. So draw tooltips in GUI is where we want to handle that. So fn draw tooltips, map positions. Okay, hidden. Let hidden equal ecs.read storage hidden. All right, we're probably going to do another exclude. So mouse position, blah blah blah, tooltip, and in here we're going to say not and hidden. That's a really oh, it's because it's a bit set. You're nodding the bit. Oh, that's very interesting and very convenient. Wow. Okay. That should be the only changes. Doubt we're going to do anything else. So if I rerun, oh wait, oops. I didn't pull this in. If I rerun, I should be able to load because we didn't actually add any new components or anything. But now, no tooltips. The trap is there. We know the trap is there. We synced it. We know it. All right. So if you cargo run, you'll have no idea that traps are present. Since they don't do anything yet, they may as well not exist. Adding entry triggers. A trap should trigger when an entity walks onto them. So in components.rs, we'll create an entry trigger. As usual, also register it everywhere. We broke our save again, basically. So we'll go ahead and do that real quick. We'll get back. We got to add it to bear traps as well. So let's see. Let's put that there. Entry trigger. Save load system. Entry trigger. After hidden. All right. And then in main, we will register it. Entry trigger. Okay. Then we want to go on to Le Bear Trap. And after it's hidden, with entry trigger, I'm guessing when we discover it, we just remove the hidden component, and that's a very nice way. There's no revealed component, right? We don't have to explicitly reveal it. We just say it's no longer hidden. Delete that hidden component, we're good. I like that. So we also need to have traps fire their trigger when an entity enters them. Wait, what? So an entry trigger, we'll create an entry trigger when something walks onto them. We also need to have traps fire their trigger when an entity enters them. We'll add another component, entity moved, to indicate that an entity is moved this turn. Components.rs, okay, what? We're gonna see how that works. I'm a little confused at the difference. Is it saying like if they spawned on a trap that, oops. Is it saying like if they spawned on a trap, they won't activate it? I don't quite understand. So, entity moved. We're gonna add this stuff everywhere as well. Yeah, making sure we are adding it everywhere. Entity moved. Entity moved. Entity moved. Okay. And we need to register it in here. Entity moved. Okay, I'm gonna get tired of saying that. So now we scour the code base to add an entity moved component every time an entity moves. In player.rs, we handle player move. Oh, I think I know what's happening. This entity moved component is going to be what triggers the trap, right? I think we're gonna have a system that joins up whether something moved with the traps and looks for a common. I don't know. We'll see. Entity moved doesn't actually have a location on it though, so we'll see how this works. In player.rs, we handle the movement in the try move player function, which is right here. At the top, we'll gain write access to the relevant component store. Let mute entity moved equal ECS.write storage. Boom. Entity moved. Oh, I forgot the double colon. I saw a post. Was it on the Rust Reddit or something earlier? There was someone asking, how do you pronounce double colon? I say double colon. There are people, I forgot, there are all kinds of weird names. Some people are saying they just omit it, right? Like you'd say right, and I kind of do too, but if I'm typing, I usually say, because it's like a tactile thing almost. But you might also say write storage entity moved. That's usually what I'll say. If I'm just kind of reading over it, I'll omit it. You'll have like RLTK. I won't say it here. RLTK double colon cut. No, I'll just say RLTK console point. RLTK. You know, it depends. It was an interesting topic, I guess. And you have a lot of people. This one, I never heard this until like a couple weeks ago on a YouTube video. Some people, instead of STD, they say stood. I don't like. I hate that. I hate that so much. Decol, yes, that works. That works, Jaeger. Let's see. So we add that, we have right access to it. Then we've determined that the player, when we determine that the player did in fact move, we insert the entity moved component. So I'm just confirming where that's going to be. If position plus, okay, so if it's, okay, that's it. Yeah. This is if we're attacking. If the map is not blocked, then this is where the real player movement happens. So I guess we want to put it in here. So we'll say entity moved dot insert entity moved dot expect unable to insert marker. So my justification here is essentially we only do that if the player actually moves, right? So this check here is saying if the X position goes below 1, which is the border of the map, which is like going onto the border of the map, we're not allowed to do that. Or if it goes to the right, to the right border of the map, or, same thing for top or bottom. We return. We don't let the player do that move. Then we actually check that tile that they're trying to move to, and if there's a target there, we actually add this intent to deal damage to the target. The wants to melee intent, basically. But then we're not moving, so we don't want to do that there. And if the map is blocked, basically this happens if the map is not blocked. So this is the only time we're actually going to be moving is if that map is not blocked. So in this conditional. So that's my justification for putting it here. I can double check their code, but I think we're going to be fine. So I'm just going to trust in my own justification for now. And we're going to add this entity moved, which is tied to the entity itself. Basically saying whatever it is that did the movement, whether it's a player or an enemy, that is the entity here, and it now has entity move component. That's why we don't need to attach any position to it, because it's actually on the entity that did the moving. That makes sense. So the other location that features movement is the monster AI. Well, actually, yeah, that's just player movement, so we do have to go to the monster AI. Never mind. So in monster AI system.rs, we do something similar. We add a right resource for the entity moved component. And the way we're going to do that here is right, wait. Yeah, right storage. Oh, see, they're doing a thing I don't like. Now let's take a look at this, okay? Let's take a look here. What is the last thing I have? I have particle builder, right? Oh, this is monster AI. Hang on. No, that's it. Why do I have particle builder there and they don't? Am I blind? Particle builder. We're definitely using it. Okay, this complicates things even further. Oh, that's why we're making a new system. Okay. I see what's happening. We're actually making a new system. Oh, no. Okay. No, I'm sorry. I'm getting too ahead of myself. All right, let's look at the page here and collect my thoughts, because that's probably very confusing. So I'm looking here and it's like we need to add the right resource and all this. And then I see the code here, but this is for trigger system, which doesn't exist yet. But I was looking at this, I'm like, this does not at all match up with what we have here in the monster AI. Well, of course not. It's for something else. is this thing popping up? You don't see it, but something popping up, reminding me to update software that I said remind me later on, like literally 2 hours ago. I don't need a reminder that quickly. Alrighty. So anyway, now that that distraction's out of the way, we're gonna do right. It's not a resource though. So it's write storage. The tutorial does call it a resource. It says write resource for the entity moved. It's not a resource, it's storage. Because a resource, there's only one of in the entire ECS. So this is going to be entity moved. And now we need to put it in here. Entity moved. Mute entity moved. And then this is where path to the player. Yeah, we add a write resource and insert one after the monster moves. The source for the AI is getting a bit long, so I recommend you look at the source file directly for this one. No, I'm going to try and do it. I just want to make sure I understand where the move happens. If the distance is less than 1.5, then they attack. Else if visible tiles contains the player. And then this is where they move. Get the index. Map.blocked is false. Map.blocked is now true. Okay, yeah. View shed is dirty. So I think we should just be safe putting this anywhere in here because we have a successful path. So now we're going to say entity moved.insert. Entity, is that what we're calling it? What's the name of the monster? Yeah, it is entity, okay. And it's going to be entity moved with nothing on it, .expect, unable to insert marker. We called it marker before. Okay. So that should be fine. It's not explicitly being shown in the tutorial, but I think that all makes sense to me, and I think I've just justified why it's here. So we should be fine. So now it's time for a new system. We need a system to make triggers actually do something. So we'll make a new file. Let's collapse resources there. And this is going to be called triggersystem.rs. I'm going to scooch up here to the top. Mod trigger system. And in that file, what are we going to be doing? We're going to use a bunch of stuff, so I'm going to cheat and copy that. Pub struct trigger system. And we're going to do an impl for it. This is a system, so this is pretty standard at this point. We're going to give it lifetimes for trigger system, and we're going to make Clippy. We're going to appease Clippy. Type complexity, appease Clippy. System data, and what do we need? We need a bunch. Read, expect. So I am going to type these out because we're making a new system here, and I want to get a feel for what's going to be happening. Write storage. It's going to be entity moved. I missed a comma. Read storage. And it's going to be position. So, okay, so let's justify write storage. We're probably going to be deleting the entity moved after we process that it triggered a trap. Easy enough. Read storage, we need to know where the entity's at. Read expect. We need to, I guess, get map data for the indices and all that, maybe? We'll see how that actually... Well, we might be revealing... no, I don't know. We're going to see how that works. I'm not sure about map yet. It's just read, so we're not modifying anything. Read storage entity trigger. We don't have that? Oh, entry. Yeah, entry trigger. Sorry. Entry trigger. Okay. That makes sense, right? We're triggering a trap. Not anything special there. Write storage. It's not, it is just read storage on that. We're not getting rid of it. Write storage on hidden, so it's going to unhide it probably, so we do need to modify that. Read storage. Name. We want to know the name of the trap. Entities. And finally, write expect game log. Expect is how we signify that it is a resource, right? Boom. There it is. Implement missing members. We have system data. Now I'm going to cheat on this. To unpack data, I'm just going to copy their line because I don't feel like typing out map, mute, entity, move, position, blah, blah, blah. Oh, that's a lot, right? Map, mute, entity, move, position, entry, trigger, mute, hidden, names, entities, mute, log, equal data. Skip that. Alrighty. Now for the actual system. It's not terribly long, but it's heavily nested. Cyclomatic complexity is getting up there a little bit. I think that's what you would call that. Iterate the entities that moved and their final position. For entity, mute, entity, moved, position, in, entities, and mute, entity, moved, and position, dot join. So we're mutating entity moved, but we're not actually using the entity moved component, probably because we're removing that component. So it's going to be interesting to see. I don't know if it needs to be mutable here, because we are doing entity move.clear after the for loop. Odd. Whatever. We'll get to that when we get to it. All right. Let index idx equal map.xy idx, and it's position.x, position.y. Now for entity ID in map.tile content idx.iter. So what we're doing, we're going to loop through the map tile where we're at, and we want to check if there are any traps, right? If entity not equal star entity ID. No, okay, let's see. Do not bother to check yourself for being a trap. That's what it says. Yeah. I had to scroll over to confirm. Let maybe trigger equal entry trigger dot get entity ID. Match maybe trigger. None does nothing. Some. Do we actually? Yeah, we don't care about it, but we do this anyway. Oops, why did I put that there? There we go. I was like, something's odd. All right. We triggered it. Let name equal names.get entity ID. If let some name equal name log dot entries dot push format so name dot name. Then hidden dot remove. Trap is no longer hidden. Now the last thing we want to do here, again after the for loop, Remove all entity movement markers. Wonder why we made this mutable. We should be able to get rid of mute here and here, should we not? Don't see Rust complaining. But it's also not complaining that it doesn't have to be mutable. So I'm a little bit intrigued by that. Normally it would be complaining. We're not using it. We're underscoring it. We're not using it, so it shouldn't need to be mutable. The only mutable thing that's happening to entity moved is not part of the loop. It's at the very end of the system where we just clear all of them. So let's break down the system a little bit, because there was it's heavily nested. There's like a lot of loops and stuff going on. So let's break down what's happening. It's not too bad, I don't think, but you know, I kind of get into the zone as I'm copying the code over, so I might benefit from it as well. So we want to get all entities with entity moved component and position component. And we convert their position to the map index, and then we loop through the contents of that tile that they're on in the map. Now we do a little sanity check here to basically, I'm going to scoop this above the if, because the auto formatter I did have it to the side of the bracket and it moved it, so we'll do that. So don't bother to check yourself for being a trap. So just saves a little bit of time there. We're just checking to see if the current entity is also the same thing in the tile, meaning the player, monster, whatever, right? So if they're not the same thing, it's two different entities, we'll do the comparison now. We say maybe trigger because it's an option. We just get that entry trigger. We get that entity ID from entry trigger. If there is a match, then we triggered the trap. Now again, let's go back to spawner real quick. Yeah, entry trigger is actually the thing that makes the trap work. Okay, so that's what we've actually put on bear trap. It has hidden and entry trigger. Those are the only things it actually has. So any trap should presumably have entry trigger, but it doesn't have to be just a trap actually, right? I mean, probably at this point it does. We'd have to refactor. No, we wouldn't. Yeah, no, we wouldn't have to. I was going to say we could make it do other things. Like we could walk into a tile and then it opens a door somewhere. You know, you could make it like a pressure plate or something. So yeah, you could do a lot of things with that. Because right now we're not really defining what happens, are we? We're just saying if that thing does have an entry trigger component, that thing in the tile, then we get the name and we say that thing, whatever the name is, triggers. And then we remove the hidden component from the entity that we're on. Does this, we're making an assumption that it has a hidden component. Does remove, I think it returns an option. So the option probably tells you whether or not it did remove something. What I'm intrigued by is that we're just blindly removing the hidden component, but it could, what if it's a trap we've already revealed? I think it still works, but just an interesting bit of logic there. And then finally, that was it. We do that for everything in the tile, so there could feasibly be more than one trap there or whatever that would trigger. And because we're not breaking or anything, so we're going to keep looping through. And then once we're done with all that, we just remove every entity moved component from the game, because we're doing this for every entity moved component in the game, so we don't have any more to process. Again, that's how most systems have been working. We do all the stuff, then like that's it. In many cases in our systems, we do clear at the end because we no longer need those. All right, so back to the tutorial text. This is relatively straightforward if you've been through the previous chapters. We iterate all entities that have a position and an entity moved component. We obtain the map index for their location. We iterate the tile content index to see what's in the new tile. We look to see if there's a trap there. If there is, we get its name and notify the player via the log that a trap activated. We remove the hidden component from the trap since we now know that it is there. We also have to go into main.rs and insert code to run the system. It goes after the monster AI since monsters can move, but we might output damage, so that system needs to run later. Now that's important. I've talked about this before. I don't know that we've really talked about it in the tutorial itself, but I've talked about the fact that the system order does matter quite a bit. It hasn't been an issue yet. Not too much. I think it has been a little bit of an issue. Drop and I don't know. Yeah, melee combat needs to go before damage, probably. Otherwise, you'll be like one turn off. It'd be kind of weird. All right, so we do the monster AI. Yeah, we do monster AI, and then we do the trigger system. There we go. So now we can do all that fun stuff. If we go into the game, we start up a new game, run around until we find a trap, which shouldn't take long. We should at least see it trigger and appear. Oh, there we go. Bear trap triggers. And it's there now. All right. Quit. Next, we need traps that hurt. So that gets us a long way. Traps can be sprinkled around the level and trigger when you enter their target tile, but it would help if the trap did something. We actually have a decent number of component types to describe the effect, and spawner.rs will extend the bear trap to include some damage. So inflicts damage already exists, so we'll go to spawner.rs, and after entity trigger, we'll do a dot with inflicts damage. 6. That's a big old beefy boy. We only have like 30 health, right? We don't level up or anything yet. If we're ever gonna add that. Actually, that's something, we did that in the other tutorial, right? We haven't done that here. Oh, that's coming up that's like way after the maps and stuff. Okay, that's fine. I mean, we could do that. We could add an XP component and attach it to all the monsters, and then have like a component on the player that tracks like their level and stuff. I don't know, whatever. You'd have like maybe, would you do it with a system? You have like a level up system or something that if you should level up at like, I don't know, you'd have to do a menu if you wanted to have the player choose what stat to work. Whatever. We can just think about it if we want. And it's really, it depends on how you want to do the level up, which depends on how you implement it. If you do automatic level ups, you probably would do a system. If you want some player interaction, you would probably do a game state, and have a new menu pop up. So I think that's what really does the most there. If you want to do automatic level ups and have like growth formula, you do a system, I imagine. Just have it happen on its own. We have the damage. We don't need to add anything else. We'll also extend the trigger system. So let's find it. The trap is damaging. Okay, yeah. So that's where it's going to get interesting now. So we triggered the trap. It doesn't matter when we do hidden.remove, so we'll just go here and we'll say if the trap is damage inflicting, do it. So this is what I was saying. Now the behavior for the trap, we say trap, but it could be anything. It could be a pressure plate that opens a door. It doesn't have to be hostile. So we could have all kinds of different behaviors here. And that means we do have to have essentially if blocks for all of them. Or we could maybe find a better way to abstract that out and have it be a little more generic. But that could be, it could be interesting. I'm not sure. Immediately as I'm just Pontificating on it, I don't know. Don't know the best way to do it. Let damage equal inflicts damage.get entity ID. Now inflicts damage is going to be mad. We're going to need that. I'm just going to slap it on the end here. Where they would have put it, but I'm going to just put it on the end. I don't think we need to modify it. So, yeah, no, we shouldn't have to modify it. So, read storage inflicts damage. There we go. So now we get that damage out of there. We're going to do an if let sum damage equal damage. Particle builder, which we don't actually have either, do we? So that is a resource, which is going to be read write expect particle builder. We'll say particle system particle builder, and that means I'm going to need particle builder. Trying to remember how we named everything last time. So now what we actually do, if there is some damage, basically if we found that component on inflicts damage.get entity ID, then we'll do particle builder dot request position X, position Y, RLTK RGB, named RLTK orange, and RLTK RGB, named RLTK black, RLTK 2, CP437. Ooh, what was this? 19? Alt 19? Yeah. Hold Alt, hit 19 on the numpad, and then you get the double exclamation, the double bang. A lot of people call exclamation mark bang in programming context. Cannot borrow is mutable. Did I not? Oh, I made it a write expect, but I forgot to call it mutable here in the destructure. In my brain, when I say write expect, I'm already thinking mutable, so I often forget to do it right here. That's fine though. All right, so we get our little particle to show the damage is happening. And then we want to actually do suffer damage, new damage, and mute, inflict damage. Is there a typo? Hold on. Let damage equal inflicts damage dot get. We'll take a look at this in a moment. There's something weird. Entity, and this is going to be damage dot damage. Expected struct components suffer damage. Found inflicts damage. Okay, so the tutorial. So what threw me off? Look at this. And mute inflict damage. But we have here inflicts damage. Two different things. I think this is actually the suffered damage store. I think that's how we've used it before, but it's using like almost the exact same name, which is concerning to me. So if I understand this right, it's going to be inflict damage. mute, and it's going to be write storage, suffer damage. I do not like that naming. I think that naming could be a lot better, but this should match what they have. I don't like that naming. We have two things. One of them is plural, one of them is singular. It doesn't really read very well. So no wonder it confused me for a moment. If you cargo run and walk around, you can, if you cargo run now and move around, walking into a trap will damage you. If a monster walks into a trap, it damages them too. It even plays a particle effect for attacking. Boom. Begin new game. Probably nothing in the starter room. I just have to like sweep the rooms until I find one. That's the problem with making them invisible. I want a good system for discovering the traps. I don't know how we do that. Maybe just waiting. How does NetHack do it? I don't remember. It's been a while since I've played NetHack. Oh no, I thought it was the hunger kicking in. Isn't it still like 200? Should be like the first thing we find. The rooms being empty is suspect for sure. Yeah, so unless I don't think I broke anything, but unless I broke something, like the first item we find could feasibly be a trap. We just won't know it until we see it, until we step on it. Oh, there we go. All right, health potion. I'm at 24, I'm at 18, I'm at 12, 6. If I do it again, I die. Boom. All right. Took a little bit, but we got it. Cool. So now we have another feature that we want here for the trap. Bear traps only snap once. Some traps, like a bear trap, think a spring with spikes, really only fire once. Seems like a useful property to model for our trigger system, so we'll add a new component, which is going to be single activation. My guess, let's go ahead and just think it through real quick while I'm adding it to components. My guess is going to be that it's something along the lines of removing the entry trigger. That's it. We remove the entry trigger if this component exists, right? Oops. Single activation. Save that before I forget. Single activation. And we put in our save load, all that good stuff. All right, now. Oh yeah, we need it on the bear trap as well. That would make sense. Spawner.rs with single activation. Boom. Beautiful, just like that, so easy. Now, it's there, but we're not doing anything with it, so we're going to modify the trigger system to apply it. Note that we remove the entities after looping through them to avoid confusing our iterators. Ooh, the trigger system is looking beefy. Let's go to the trigger system. So, let's take a look at what we have here. I'm reading down the line on theirs. We're going to compare mine. We have map, entity move, position, entry trigger, hidden, name, entities, game log, inflicts damage, particle builder. They didn't do it with the particle system here, but it's the same thing. Suffer damage, and then single activation. So read, storage, single activation, and then, yeah, they totally did that weird inflict damage thing. Why would you have them both with such a similar name? That's really difficult to follow. I don't like that. Really not a fan of that one. I think that could have been a much better name, like Suffer Damage, like what it's called. Anyway, we'll go with it. We'll trust the tutorial gods for now. Just, I find that very confusing. That would be my biggest complaint maybe so far. I complained a little bit about some of the refactors being a little bit vague at times, but I think that would obviously honestly be a bigger complaint for me because it's very confusing to read. It looks like a typo at first down here, right? Without the compile or the IDE giving you type hints and stuff, you're like, oh, the S is missing. You made a typo. Yeah. All right, I'm gonna stop. All right, so what are we gonna do? Iterate the entities that moved and their final position. Let's see, let mute before the. Okay. It's even before that. All right. So let mute remove entities vac entity equal vac new. Alrighty. It's going to be mad because we're not using it yet, but that's not a problem. Let index for entity ID. Don't bother checking yourself. Okay. And they put hidden remove after this. It doesn't really matter because it's all going to happen regardless. But I'm going to make mine in parity, as I like to say. So if it's damage inflicting, do it. And then after that, probably exactly what I stated earlier. If it is a single activation, it needs to be removed. Let SA equal single activation.get entity ID. If let sum SA equal SA, remove entities.push entity ID. And then what did the thing? Note that we remove the entities after looping through them to avoid confusing our iterators. Yeah, that actually, yeah, that's good. Okay. I was wondering that comment, but it makes sense now. Basically, if we're running through iterators and stuff, we don't want to be modifying them at the same time by like changing the, essentially this is changing the bit set around. Although we did not actually include this in our join, I guess it could still lead to some oddities if we do that. We'll trap in remove entities.iter, and we're going to do entities.delete star trap expect unable to delete trap. All right, so I 100% called how this was going to work. Basically, we just check to see if the component's there, and if so, we remove the entity. Actually, I would prefer to do it another way, though. It's not actually 100%. What I would prefer to do is remove the trigger, but keep the trap there. It's like an activate, like it'd just be a bear trap sitting on the ground that doesn't activate anymore. It's renderable, it's no longer hidden, but it won't activate again, because the only way this ever activates is if it's well, no, it's entity moved. Oh no, the trigger, yeah, it requires the trigger. So if we removed the trigger component, I'd kind of prefer that. If you cargo run now, and then he says, I recommend cargo run release, it's getting slower, you can be hit by a bear trap, take some damage, and the trap goes away. I'll do a release, why not? It'll take a little bit longer to build, because I haven't done a release build on this folder yet. I don't know how much slower the game's really getting, to be honest. I don't have a frame rate counter, so I'm not sure. Probably print it. We've already seen that the game gives us a frame timer. We saw that last time with the particle system. We used a ctx.frametime or something. Alrighty, let's find a bear trap. Should have made it like stupidly high. Oh, there we go. Bear trap triggers. And if I walk over it, it doesn't happen again like it did last time. There we go. So we left a blood stain, but it'd be kind of nice if the trap was still there. Personally, not a big deal. Personal taste. You could do exactly what I suggested if you want. Basically, instead of deleting the entity, you would do, what would it be? What's it called? Entry trigger. Dot delete? No. Dot, oh, I know why. Oh no, that's it. Yeah, entry trigger dot. Wait, I thought we've done this before. Sorry, now I'm confused. I thought we just deleted the hidden component. Hidden dot remove. Am I hang on. Oh, you know why? Because it's not mutable, right? Entry trigger is not mute, and this will probably be mad. Oh no, not yet. But it doesn't meet the requirements yet because we need to make this write storage. Then we can do it. Entry trigger dot remove star trap dot expect blah. In fact, I want to see this in action. I bet it's going to work. Maybe it doesn't. We're experimenting. We're learning. Let's do it. We're a little over 2 hours, but we're not doing too bad. We're basically at the end of this section. There's another little bit we're going to do. We're basically at the end, so it's all good. That's a big old room. There it is. So it triggers. We lost health. I step on it again. Look at that. It doesn't activate again, but it's still there. So see how easy that was? Now, this is personal taste. If you want the trap to completely disappear, go for it. It is removing something from the game that does have to technically be processed. But I don't know. I almost prefer that. We don't get the blood stain because that trap renders over the blood stain. So, ooh, another one. Oh, man. So again, it's up to you. Again, personal taste, right? But I thought that's what we were gonna do because, again, to me, the idea of the trap just going off into the ether is a little odd. So I quite like this. Now we're finding them. I had a hard time finding them earlier. Yeah, there we go. There we go. All right, let's bounce on out of there. And we'll go back to the way the tutorial defined it. But see how easy that was? Such a simple little change. We make that mutable. We make that right. And that's all we had to do. And we just delete that. We remove that entity trigger rather than deleting the... Excuse me, rather than deleting the whole entity. All right. Now, we're almost done. So let's do that last little bit. I'll try to do my stretch goal for the map too, because I think we'll have time. This is a big old beefy system though. I might cheat and copy through the system data and stuff. But I'm going to break down all the system data before I write anything. So spotting traps. We have a pretty functional trap system now, but it's annoying to randomly take damage for no apparent reason, because you had no way to know that a trap was there. It's also quite unfair since there's no way to guard against it. We'll implement a chance to spot traps. At some point in the future, this might be tied to an attribute or skill, but for now, we'll go with a dice roll. It's a bit nicer than asking everyone to carry a 10-foot pole with them at all times, like some early D&D games. Since what do they just like poke the tile? Is that what happened? I don't know. Since the visibility system already handles revealing tiles, why not make it potentially reveal hidden things too? Oh, so yeah, this is I forgot. No wonder it sounded familiar. So here's new code for visibility system. So we're gonna have to just mush this in. So this will go quicker than I thought. Visibility system.rs. Now it is way beefier. We're gonna go from map, entities, viewshed, position, and player. We're gonna add hidden, RNG, game log, and name. So I'm gonna copy from the breakdown of the data all the way up to the impl there. So let me, oh my God, let me get over here. We're gonna just paste over that. Hopefully I didn't make anything too mad. No, we seem to be in good shape. Include these. I could do this with the keyboard, right? Yeah, I should be doing it that way. Okay, there we go. We got the shortcut there to get these new things in. Now I got to break down what's actually happening. For int viewshed position and entities, mute viewshed and position.join. That's all good. Viewshed is dirty. We do a bunch of stuff. Visible, retain, all that fun stuff. Okay. Viewshed dirty. Well, false. They do it in a different order, I guess, but it doesn't matter. Okay. Actually, no, we're changing some behavior, it looks like. Visible tiles.clear, I don't see on here. Hang on. Oh, that's not here anymore. Interesting. Well, okay, no, I guess it makes sense because we're overriding it with the new field of view, so why waste time clearing it? Okay. No, why was that there, though? All right, so we're gonna do set it false, do visible tiles equal field of view, blah. All right, nothing should change there. And viewshed.visibleTiles.retain, that closure is just, yeah, okay. Nothing crazy there. Okay, just retain things that are in the map, that are in the game. If it's a player, reveal what they can see. We get the player. If let some, okay. For T in, okay, that's the same. Now this is where it might be different. For viz in viewshed.visibleTiles.iter. Let index equal that. Map.revealedTiles is true. Map.visibleTiles is true. Now, chance to reveal hidden things. For E in map.tile or tile content.iter, oh no, idx.iter, because we're actually getting into a specific tile. Then we're iterating over what's in that tile. Let maybe hidden equal hidden dot get star E. If let some maybe hidden equal maybe hidden. Just a way to destructure that. If RNG dot roll dice 124 double equal 1. Did I type 1 or 2? I swear I typed 1. I swear it just changed to a 2. I might be going crazy. Let name equal names.get star E. And if let some name equal name, log.entries.push, format, you spotted a blank. Name.name. And after that, hidden.remove star E. So a couple things stand out to me, but this is pretty straightforward. We check everything in the tile. We get a hidden component. If there is a hidden component, we do a 1 in 24 chance of revealing it. We get a name. If there is a name for it, we say that you spotted it, and then we remove it. I find that interesting that we could have something without a name, but that's fine. And then, is there anything else I want to read? No. Well, yeah, we'll actually read a little bit ahead on the tutorial before I run it. So why a 1 in 24 chance to spot traps? Well, I played around until it felt about right. 1 in 6, my first choice, was too good. Since your viewshed updates whenever you move, I was actually going to comment on this too, but since it updates whenever you move, you have a high chance of spotting traps as you move around. Like a lot of things in game design, sometimes you just have to play with it until it feels right. If you cargo run now, you can walk around and sometimes spot traps. Monsters won't reveal traps unless they fall into them. Yeah, because this is in the player section of the view shed, so that's important. And that's actually a comment I've made many times. Sometimes you just have to play with things until it feels right. And I was going to make the comment 1 in 24, just analyzing it, just from the code here. There's something that like immediately stands out and makes sense to me. That turns in this game are very fast. As you're moving through a room, your view shed covers a wide range, and just moving through the room like bop, 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 every square is a turn, and every square has that 1 in 24 chance. So you actually have quite a few 1 in 24 chances of finding that trap. See? And we just found one already. So now we can be an idiot, and we can step into it and take damage. But there we are. All right. So that is actually going to be it. What's going on, Slater? What's going on? Jaeger, what did you say? I always feel, oh my God. I am winning. Well, I guess. Alrighty. Wow. Oh yeah, I forgot we still have the traps jacked up. All right. All right, let's head over to the spawner. Where's it at? So we reveal traps, everything works fine. We're gonna bump this thing back down to 2. We don't need to be finding more traps than anything else in the game. So now if we want to have a little fun, we can run through it until we find a trap. Fun thing is, that's gonna be the end of the main stuff for the day. So took a little bit, about 2.5 hours, right? But that's not too bad, considering it was a lot. 3 sections, and lots of content, lots of new features in the game. Rather than actually doing this right now, you know what I want to do? I want to do the little stretch goal I made for myself earlier, just to see how well it would look, how it would work. So let's give it a try. Let's quit. What we're going to do, we're going to add this little stretch goal I came up with earlier. This is my own thing, not in the official written tutorial. I'm making it up as I go, but I had an idea. And the idea was to use the particle system to make our map reveal thing look better. I'm not saying it looks bad. I think it does look cool, but actually let's get another look at it. Magic mapping scroll. We're going to say 200. They'll appear all over the place. Let's get a look at it real quick. Take a moment and pop into a new game. It should be basically the first thing we find. Magic mapping. Boom. That's not bad, right? Brrr, I kind of like it. It's kind of nice. I want to try one other thing with it though. So my idea for the stretch goal, if you will, is let's go to magic map reveal. And I want to do one more thing. So here's what we do. For every tile, and this may look awful, right? But for every tile, we get the index, and then we simply set it to true. But we do that on each row, so it's one row at a time, and that's why we get that nice effect going down. I want to see what it looks like if we do something like this. We need the resource. You'll see in just a moment. So I need to get the ecs.fetch self.ecs.fetch. Actually, let's do that up here because this would be terribly inefficient. Mute, and it's particle system particle builder. So we're gonna get our particle builder, and then for every one of these, we're going to do particle. Oh, oops, I should probably assign it to something. Let mute builder. Okay, particle builder dot request. So we're going to put a request in there. And it's going to be X, not S. X. Y is going to be our row. And foreground is going to be RLTK, RGB, named, and I'm going to make it cyan, whoops. Named, it's going to be RLTK cyan. It's the first thing that comes to mind. RLTK RGB named. RLTK black. The glyph is going to be RLTK 2. Okay, we're going to do this. I'm just going to do an asterisk and see what it looks like. We're going to do like an X or something even. X might be better. And lifetime is going to be 200 milliseconds. It's going to be pretty quick. And X as I32. Okay. Cast that. And that's it. We're going to see what that looks like. It's going to put some little things up, and then they're going to fade away, and it's going to reveal the map behind the X's, kind of. It might look horrible. I might not like it, but I just want to see what it looks like. Extra little things popping in. I could even make the effect last longer. Let's see if it looks horrible or not. I think it was too fast, wasn't it? 200 milliseconds is too fast. Let's try a second. I couldn't even really tell that anything happened. Oh no, I know what happened. We're not updating the systems, are we? No, we should be. All right, take it easy, Slater. I'm about to wrap up anyway. Thanks for stopping in, though. Hope you're having a good one. Hope you do have a good one. Hey, get out of here, Goblin. I'm trying to reveal maps. Wait, how did I get a shield when this is supposed to spawn so much more? Scroll of magic mapping. Let's take a... You gotta watch quick, because it's gonna go quick. No, that's not what I want. Oh, I know why. I forgot the particle system... I did see that a moment ago. The particle system only happens for things in your view shed, right? Is that how it worked? Let's take a... It might have been a bust. Let's take a look at the particle... call dead particles, I don't care about. Renderable. Particle lifetime. Yeah, so it's renderable. Has a position, it's renderable. But what that means is, because it's not part of the map and it doesn't have that special code, we would need to add special code to always render particles, which would be maybe okay, but also potentially odd. In draw map, we could also... do things that are particles. I'm trying to think of the... Oh no, we could... No, draw map is in here, my bad. So we're drawing everything that we should be drawing. We wanted to add extra goodness, which would... Yeah, you'd almost have to make it part of the map here. Which is odd. You wouldn't want to do that. It's not. So you would have to add a bit of a different rendering system for those particles. I don't know if I want to go that far. Just for a little thing that I'm going to get rid of here in a few minutes. I don't know if I want to go that far. But let me think. Let me think about it for just a minute. So what we're doing here is we draw the map, which is just the map. And then we draw all the other stuff we need. Everything with a position that's renderable, that's not hidden. And we sort by the render order, and then we actually draw those things. And what actually happens is the particles do get filtered into this. This is how particles are being drawn, because particles have position, and they're renderable, and they're not hidden. They satisfy all three components. The trick would be also drawing them if they're not in visible tiles. And the thing is, we would have to do another join, basically, And I could do a really hackish thing here. And maybe that's worth doing just to do it. So we'll say let particles. What were the components? I don't remember. Particle lifetime. Is that the only? That's the only one we care about. This is really going to be really hackish because this is not how the system was designed. But it's fine. We're going to do read storage on that particle lifetime. And now we're going to basically copy this. Again, this is super hackish. Don't do this. And copy that. All that's fine. Instead of data.iter, I'm going to copy this and just add an extra thing to it. We're going to remove all this. It's going to be join. Positions, renderables, not hidden, particles. Oops, extra comma there. All right. For position, render, particle. Wait, did I do something wrong on that? Do I have to collect and do a vec like that? And I think we normally do that. The method join exists for tuple. It's trait bounds. What am I doing wrong? Hang on. Let's see. There should be another example of it nearby. Actually, we don't really do any joins in here, do we? Entities.join. Where's that at? Join, collect. Position, render, particle, hidden. Is something odd about this that I'm not catching? What is it? Let's try to make this a little bit more like the piece above. Might help. Oh, you know what it might be? Read storage, no, that seems fine. Trait bounds were not satisfied. Trying to figure out what it is. That's a bit of a difficult one to parse there, but I'm trying to figure out what it is that's not satisfied. Particle lifetime is a component, yes? Has to be. Yeah, particle lifetime. We've registered it as a component. Thought this was going to be really simple, and now I'm just, something weird is happening. Well, we are going to replace this on data.iter. Gonna get rid of all that other stuff. All right, so doing a little better there. Cargo build. Let's see. Doesn't satisfy specs join. Pub struct storage. Masked storage components. What? There's like nothing different about these. In fact, I'm going to copy this line. Particle lifetime. Particles. Making sure I didn't somehow define that incorrectly. Wait a minute. Is it related to... It is, isn't it? No. No, because if it was a borrow checker thing, it would be a different error. Never mind. We're going to do that data.sort by down here as well. But I just don't know why I'm getting this issue here. Like, if I get rid of that, it's fine. Something about particle lifetime is not working. So now it becomes a new question. What's different about particle lifetime in components? Particle lifetime. Like we have hidden in there. And component, debug, serialize, deserialize, clone. Component, it doesn't have debug. That's not going to change anything, right? That's to print it. We don't care about that. Storage. It is, I mean, it's talking about particle lifetime. I am legitimately at a loss. Storage, position, fetch, all that fun stuff. Positions, render. Oh my god, I feel like an idiot. I missed the reference on it. I see it and I'm like, oh my god, it was so simple. Okay, now we should be fine. And I could have done it without as much boilerplate here probably, but doesn't matter now. We actually want to sort it probably anyway, so that's fine. So now we're doing this just on particles for the whole map by getting rid of this visible tiles thing. Don't need this. All right. That became a mess. Let's see what happens now. If I did this right, we're going to get a full map effect. It's going to last a second, which actually is a bit long. Let me kill the game real quick. Let me reduce that. Where is it at? Let's do 400 milliseconds. 200 is a bit quick. We'll try 400. You know what would be fun? I got another idea we might do in a minute. Begin new game. Give me a scroll. All right, watch closely because it's going to go quick. Nope. Oh, you know why? Yeah, okay. Nah. It's still a bit of a bust, and there's a reason for it. We would need to basically update systems here. So I'm curious. This is getting more and more grotesque as I continue this. There we are. Satisfy the borrow checker on that. This is getting more grotesque, but we're going to say run systems. This is bad, by the way. Don't even tell me. There are problems because it's going to run the hunger clock for every row. Basically, when I run this, I'm going to get way hungrier than I should be. So I understand that. What I'm trying to do is just take a look at you know, how this is going to play out. What you'd probably want to do is explicitly run the particle system What was it? Yeah, you probably want to explicitly just run the particle system. This is a hackish way to get it. I just want to see what it looked like. That's all I care about at the moment. What would it look like? One row at a time, basically, with the extra little effect. Oh my god. All right, here we go. That wasn't horrible, but it wasn't as good as I'd like it to be. I mean, it was fun to do it. Maybe the... Where'd it go? Lifetime. Oh, request. Maybe the 200 would be fine. We'll give it like one more go here. But maybe 200 would be fine. I mean, I did what I wanted to do. I set out. I made that dumb mistake with leaving the reference off on the join. And that's what I get because I haven't done a lot of those manually. I've been doing the tutorials, so it's one of those things where you autopilot it. There we go. It's one of those things where you autopilot as you're typing it. That's on me. All right, watch closely. Yeah, it's not great. I mean, it's, I don't know, maybe someone's like, that's cool, I like it, I want to do that in mine. If for some reason you're watching this and you do want to do that on yours, don't do it the way I did it. Do it better. This is the problem. Because, damn, we already... If I load the game, we should still see everything. We've already lost our hunger, basically. Let me start a new game. Why does it keep loading the... Oh, did I break it with the way we're handling this now? What? Did I break something? Alright. Look at this. We are... Damn it, we're not well fed anymore. Begin new game is not doing what it's supposed to. I think that's broken. We might look into it, we might not. Alright, we are well fed. But watch what happens. In fact, we're probably gonna die. No. Okay, no, we're still well fed. Maybe it's not as bad as I thought it would be. Alright. I'm gonna remove all this now, so bear with me. Because I went down that little rabbit hole. It was fun to check. It was fun to try. But I'm not super excited about it. So we'll bop that particle builder from there. We'll get rid of that request for the particle builder. We won't run the systems here. That's already an improvement. Let's just run and make sure... My question is, the way I was running systems, was that breaking anything? That new game not working right is odd to me. Begin new game. Now this will look like it did before. Begin new game is broken. Except for the first time when you start the game up. Alright, we'll look into it. We'll spend some extra time because I really want to find out what's going on with that. So now this is going to be mad because the particle stuff. So then, like, obviously this is going to be this bit here. But it's like, oh, it's this line here with data, so we'll get rid of that and the things that are tied to it. And there's no data, and there's none of this. So actually, there is data from up there. So we'd have to get rid of this one as well. But this is still non-existent stuff, so get rid of that. Everything's fine now. Okay. That's still going to be broken, so we're going to go to the menu, main... Oops, what am I? I'm in the terminal. main menu. Let's see. If new game, we do pre-run. Actually, let me try one more. Let's do something before we chase a rabbit hole. Let's do this. We're gonna run it here in the browser. Walk around, back out. It didn't. Oh, it didn't save right. But look, the problem exists here as well. It's not a bug that I made. So look at this. We fought. We've lost some health. It's all good, right? I hit escape. I have two options: begin game or quit. Begin new game pulls me back in. So the reason I was like, let's try one thing first, because I wanted to make sure. I'm about to go chase down a bug that I didn't make. And that doesn't mean I shouldn't do that, but that is a bug. Begin new game only works when you first start up the game. So we can look into that and what's happening a little bit. Main menu. So if we're on the main menu or game over, we do nothing. Yeah. So if we're on the main menu and they pick new game, we do pre-run. So run state pre-run. It shows up 3 times. We transition to it. Run state pre-run, run systems, maintain, new run state. You know what we're not doing? We're not like next level does pre-run. Run systems, maintain, waiting input. Visibility monster, trigger, map indexing. Huh. Where is the new map being generated again when we go to a different level? I feel like it was in here somewhere. Go to next level. Yeah, go to next level and then do pre-run. And what does go to next level do? It deletes like almost everything. So you know what's interesting? From new game, we basically need to do something like this. So when we first start the game, here's what we need to do. Here's what I think we need to do. All this stuff that's being done here. Where's the game? Run state. Yeah. Okay. How much of this do we need in here? Can I rip out most of this? Whoops. Main menu, that thing is fine. I'm trying to... Oh, crap. I'm on the wrong thing. I'm so sorry. I am so sorry about that. I don't know how much I just missed. It was since I was running it in the browser. Here's what I just did. There's a bunch of stuff here. I slid like a couple of these around so I could group them together. But what I've done here in main, this is all the stuff that's unique to starting up the game. Actually, we probably want to do this as well. No, yeah, we'll do that. Okay, so we're building a map. We're setting the player. We're putting our resources in. Straightforward, I guess. Okay. I'm going to cut that. And basically what I was doing was, you know, looking around a little bit, trying to decide what needs to happen when we start a new game. If they've selected new game, we don't just set the run state to pre-run. We also need to do like all this other stuff. But it's not gs.ecs now. Self.ecs. Now, I feel like I'm still missing something. But basically, we're going to build a map. We're going to set the player. We're going to put the starting message in. Welcome to Rusty Roguelike. Do our random number generator. Probably don't need to do that every time. I probably could leave that in main. Doesn't matter that much. But player entity. Put that in as a resource. We spawn all of our rooms. We insert the map. Then we pre-run our systems and stuff. Let's see if that helps. I feel like there's one more. I feel like there's a little bit more I could do. What we're doing, we're not clearing the entities, and we're actually crashed. You may ensure the resource exists. Game log. Trying to fetch game log. Where? Game log is being used. Where? All right, let's trace through. We're gonna spend a little bit of extra time today, apparently. So the first thing we do, we set our main menu, and then we go to the main loop, which actually gets us into tick. So we go all the way up to tick. And I'm looking for game log. Fetch run state, that's fine. We're in the main menu, so we skip through this without doing anything. Now we are in, what state are we in again? We're in main menu. So we skip down to main menu. Result. So we do this. We have a selection on main menu. Or on new game. We haven't actually selected it though. We have a selected option, but we haven't selected anything yet. So we should keep looping this. We shouldn't be putting anything in the log. So the first thing we should see is here. Right, I wish it would tell me where the panic happened. Maybe it does. World, no. We do backtrace. I never know how to turn that backtrace on. This is PowerShell. Let me look it up. How to set environment variables using PowerShell, because I never know how to do it. All right, let me try this. Oh, and it scrolled on me. There it is. All right. EV. Where is it at? I'm blind. There it is. Rust. Okay, there we are. Got the backtrace going. This turned into a much different session than I anticipated. State as a bracket. State as bracket terminal game state tick. Delete the dead. Why are we deleting the dead? Because it's a system, right? Or where is delete the dead called? Yeah, it is. It's a system, but we shouldn't be running anything yet, right? Main loop, event loop, a lot of stuff that's not related to what I'm explicitly doing. Bracket terminal, HAL native, main loop. Okay. Coding stream, this is it. State. Let's try running it with full backtrace. All right, it got much longer. That doesn't tell me the line, unfortunately. It's just related to state as bracket terminal game state. We implemented game state for state, right? And that's where tick is coming from, right? Impl state. Yeah, impl game state for state. Delete the dead, game state tick. Trying to, you know what I should do? I should actually say fetch game. No? Okay, someone's fetching game log. Is it delete the dead? Or there was another function nearby. Let's see. Because delete the dead is over here doing something. Keep seeing it. I can't find it all of a sudden. Damage system, delete the dead. Game log. It does. So, okay. So it's trying to fetch the. It's trying to get the game log. This is what's happening. Okay, so this gets called every time we go through the tick. I wonder, could not be better to put it in the systems. Just put this at the end of the systems or something. Huh. Well, you know what we could do? Something a bit hackish. It's not really that bad, but this. I think this would actually work. Unless something else is breaking now. Because delete the dead may be calling other things, maybe requesting other things that we don't have because of the... Nope, we're in. New game. To our map. And now we will... New game. Oh, it works, I'm a genius. New game. We're getting new maps every time. How about that? Yeah, what I was gonna say basically is that we could just say vec new. Whenever we start a new game, we overwrite this with a new resource. Not that big of a deal, probably, but we could probably there's some duplicated code now. We could probably move this around a little bit, extract this out, because I think we're doing this in a couple of places. We're doing this when we make the new map. But the difference is that when we make the new map, new map rooms and corridors, the depth is being modified a bit. I think the code is in here. Go to next level. That's the code. It's basically a lot of the same stuff as go to next level. In fact, we probably do need to delete entities as well. It's probably basically go to next level, except no, we have to make sure resources exist first, like the map and all that. We're getting the resource here. Yeah, there's a little bit of work we could do to extract that out and make it better, but hey, this is like, okay, we fixed a bug. Like, it's a dirty fix right now, but we fixed a bug that was in the tutorial, actually. The new game is not actually making a new game except the first time you start the game. Because the actual code to make the new game was in main, not in the new game call. Not in when you hit new game, right? So all we're doing is basically saying if you select new game on the menu, it should make a new game. That's where the logic is being moved to, which means a map, a player, it spawns stuff in the map, straightforward, right? But I think what was happening that was interesting is, let's go back in. I think we're keeping entities because we're not deleting everything. So we're going to see something interesting. And I did see it a minute ago. I spawned in a room with a bunch of scrolls. Look at that. There was a scroll on the wall there. Yeah. So we're keeping entities. So if I do this enough, we're going to get like obscenely populated maps, because we need to make sure that we delete everything before we actually make a new game. Look at, we have multiple players now because we didn't clear up the old. Oh, we have multiple positions and stuff, and we're moving to play. That's cool. Wait, did I attack? Player hits player for 3 health. Which was, oh my god. I attacked that other player and now I warped. I just hit down and right and I'm attacking another player. I'm gonna go left. I'm back up here. So see, I'm the one moving. Oh, this is bizarre. We broke the game so bad. It'd be an easy fix though. We just have to fix just have to fix the resources. Yeah, so we didn't completely fix it. And the fun thing is, I understand, because I actually said before that something interesting is going to happen. So I got it. Like, I saw this coming. So basically, we have to delete everything. Basically, this game over cleanup. And in fact, I could almost do that. The problem is, though, we are relying on some existing things, right? We fetch, we get the map that already exists. We can't rely on that. So write resource would fail unless we make a map first. Write resource on the point would fail. So, like, if I really wanted to be hackish about it, what I could do is make a couple empty resources, just make a quick map, make a quick point, and then call game over cleanup. I'm not going to go into more of this right now, but I think the idea is here. Basically, we need to do this same stuff, except we're doing it without guaranteed resources, which means you would you would have to make the map and stuff. You wouldn't fetch something that doesn't exist. So you'd really make a new function called like new game, and you would clean up all the entities. Could we just not do the? Hold on. Would this not actually fix the problem? Let's just find out real quick. This is the last thing I'm going to check. We're reusing those resources, but we could just override them. Would that not work? Just quick, dirty check. We're going to just keep going in a new game like before and see if everything breaks. This is still not very clean. You want to clean this up, maybe abstract some stuff where we're seeing these commonalities, this repeated code. This is not meant to be the be-all, end-all implementation of that, but there's a bug, and I was interested in checking it out. New game. There's a potion there, but that doesn't mean it's broken. What I'm noticing is we're not seeing a bunch of random stuff in the starting rooms. That scroll does not mean it's broken. I've hit it a lot of times. We're moving, we're not getting undefined weird behavior like we got a minute ago. So I think it's pretty safe to say that just deleting all the entities like that seems to have pretty much fixed it. So make what you will of that. The bug existed. Okay, we're getting, oh yeah, we're getting a lot of spawns because I said 200 still, or whatever. So the bug existed in the tutorial. I just found it. I just did a rough fix on it. You can clean it up if you want to fix it on your own end. I am going to clone the code from the repo before the next tutorial. And because of that, any fix that I do here is going to be wiped. And we'll just have to understand that there may be a bug like that sitting in the repo. It's clearly on the WebAssembly because we just saw it happening on the website. So it is what it is. You know, I don't know what else to say on that. So, okay, we did a lot of extra stuff today. We had fun with the particle thing. It didn't look as great as I wanted it to, I guess. I mean, this is one of those things I could have maybe tried asterisks, and what I was hoping was like a little sparkly kind of effect, but one row at a time, I don't know. Like, you probably fine tune it, it might look okay, but it is what it is. The idea, I did it. I made it work. Again, it was very hackish because of the way the systems are set up. That's fine. Don't worry about it. But I got it working. Just kind of, you know, stretch goals, demoing things, seeing what could and could not be done. Fixing that little bug was a good aside. And then just back to the actual tutorial now. We already read this thing before about the 1 in 24 chance. Monsters won't reveal traps. I already made my comment about 1 in 24 being a good chance because of how each move gives you that. So when you think about your view shed and then every single move being a 1 in 24 chance and anything in your view shed potentially being revealed, that's actually quite good. So, and it has an interesting side effect where if you're going through a hallway and you come to a room, but say you like step diagonally into the room, that tile was only very recently uncovered. Excuse me, sorry. That tile was only very recently uncovered, so it's very unlikely that you would have spotted it yet. So it kind of has some very interesting implications by being mixed into the view shed like that. I like it. It's cool. And as for the whole session today, I mean, what did we do? We did magic mapping, which we just played with. The Rex Paint menu was, it's one of those things that, like, feature-wise is less exciting because we're not making like a cool system. We're not making a hunger clock or traps or something, right? a map that a scroll that magically maps everything. So it's less immediately exciting, but it's one of those things that looks good, and you would want to do something like that probably in your real game. Like, I mean, you wouldn't have to. What I'm trying to say is, if you did that, people would appreciate it, but not as overtly, right? Someone's probably not going to mention it in their review, but it is something that people notice more subconsciously, and people do really appreciate that kind of thing. And that's one of those things with game design that's difficult, is recognizing sometimes that what you do is not going to be overtly appreciated, but is going to make a huge difference for how people enjoy the game. There may be very subtle things that you do in your gameplay with, like, maybe your jump height or something. That's not going to be. They're not going to be. Oh, I appreciate that I jump 47 pixels versus 43. No one's going to overtly recognize that, but when you get the feel, like, fine-tuned just perfectly, or when you get some presentation thing just right, people notice it, but they don't actively they don't actively like call it out. It's like I said this about voice acting. I don't typically think of a lot of voice acting as good or bad, because it's just voice acting. As long as it is decent, it just kind of is a thing. You don't really notice it, right? But when it's really bad, it stands out, right? Just moderate, mediocre voice acting, I don't really notice it. I don't really, because it's just, okay, yeah, they're voices. They're saying words, right? No big deal. But when it's really bad is when it stands out. So something that is just something that's actually how I want to say it. Something that just is something that people won't really notice, but they'll appreciate. And in fact, even really, really good voice acting can go unnoticed to some degree. Now, you may eventually be like, whoa, they did a really good job delivering that. You may recognize that somewhat, but a lot of people won't explicitly make that connection with something like voice acting, because if it's done right, it just sounds natural. It's just people having a conversation, right? And it's one of those things that you subconsciously appreciate. It's a weird like tangent to go down from a main menu graphic, but I do think that's one of those things where in a roguelike where it's usually just pure, I mean, that's technically still text, but it's being like painted with these ASCII characters and stuff, so it looks cool. It's an image being made out of text in a very unique way. But when you launch up, when you start up a roguelike that you know is ASCII based, and you see that, you're like, oh, cool. You know, you might actually say something, but for the most part, it's just going to be one of those subconscious things, like, nice menu, okay, just go on. But that one little thing is going to kind of maybe stick with you a little bit more than in another game that didn't do that. So that's why something like that does matter. It's less immediately exciting, but it is nice. Okay, and then we also did traps. And that puts us to the end of the stretch goals, which I did achieve my 2-stream target for that, which I like, because then next week I get to go straight into the maps. So we see generating maps in section 3. Started out as part of section 2, but I realized it was a large open topic. The larger roguelike games such as Dungeon Crawl Stone Soup, Cogmind, Caves of Qud, etc. all have a variety of maps. Section 3 is all about map building, and will cover many of the available algorithms for procedurally building interesting maps. Now, refactor map building, this is something that is probably going to be almost an entire stream, if not. I would like to do one algorithm too, or no, this isn't even algorithm, this is a test harness. This is still prepping. I'd like to do both of these on Monday. We'll see if that works out. But refactor is going to be big and beefy. We're going to make a map builder, and I guess we're going to be specifying at some point which algorithm we want to use, and it's going to like offload the work to the algorithm. We'll see how it goes. Placing the player, we have a map builder tray, we have all kinds of stuff going on here. It's going to be crazy. We're destructuring, retrieve the map and the start position from the, okay, yeah. All right, that's enough of that. Let's not get ahead of ourselves. but it's going to be a lot of work. But this is what I'm really excited for. And we may not really get to the binary space partitioning until next Wednesday. So keep that in mind. If you're watching this either now or on YouTube, it may be another session after, like the next session may just be prepping for the algorithms, not even the algorithms, but should be good. All right, that's enough of me rambling. That's enough of me going off on tangents. It is late. I need to like go get a shower like immediately, because it always takes me a while to like re-regulate my body temp and stuff before I go to bed. And I got to get up at like 5 o'clock. So, you know, it's going to be fun. And it is 21. So I should be going to bed right now, basically. But I haven't even showered yet. So, oof, bad times. All right. So it was a good time today. I'm really happy with the progress. Happy to have found like a little issue with the game. That's always fun. Again, it was fun to mess with some extra goodies there. And throw in my own ideas a little bit just to see what they would look like, you know. And even if it was a bust, it was fun to mess with. And again, maybe someone liked it, you know. And I guess the other thing, I don't know if I fully said it, but if you did like see the little X's and stuff that I put on there, you want to do it better than the way I did. You want to, like, again, I knew and I said what I was doing was hackish. We want to just get something that works, rapid prototype, then you refactor it and make it a little better, just to test it out real quick. Fine tune it, like change the lifetimes of those particles, change what the actual symbols are, look through the code table, and find, you know, oh, maybe that symbol would be good. Maybe that one. Maybe you want happy faces on it. It could be, you know, who knows, that maybe you do want them to be happy faces. Maybe the colors are, you know, you put a different color or something. It could be any number of ways that you could change that and maybe make something that does look usable. I don't really feel like the one I had was super usable, but there are options, right? Okay, so that's it. So thank you to anyone who showed up. I really appreciate it. I know we went way over, and I did a lot of extra stuff, interesting tangents, hopefully. I know I went into a lot of the code to find out how those macros stuff are working and all that. Hope that was appreciated, because I definitely appreciate it. I wanted to take that time, so I really made sure I understand like what we're working with. And then, of course, we get an explanation in the tutorial as well. So, again, thank you to anyone who showed up. If you're new, consider hitting that follow button here on Twitch. I appreciate it. I stream every day. Monday and Wednesday are the coding streams. You already know what's up here. Every other day is gameplay. 2 streams on Saturday, 2 streams on Sunday. I'm not going to break down all the games I'm playing. As for the YouTube side of things, if you're watching this on YouTube from the future, congrats on being in the future. I'd appreciate if you do all the fun YouTube stuff, like licking that like button and kicking that subscribe button and notification bell. Leave a comment. I do try to respond to all my comments. I do read all my comments and try to respond to them. I still need to go respond to something that I'm behind on. I just keep getting wrapped up in stuff. I feel bad about it, because we actually have had a conversation going on and stuff. I feel bad about it. I really do. I keep saying like every day, like I'm going to do that. And then I'm like sitting in the office or something, like I don't want to do this on my phone. All right, I'll maybe do it after my shower here in a bit, if I remember. Or my brain will betray me and I'll forget and I'll be doing something else. Whatever, though. Yeah, all the fun YouTube stuff, I already said that. So, cool. I don't think I have anything else to say. Feedback, whatever. I'm tired. It's been a long day. It's been a fun stream. A lot of interesting stuff. I'm ready for next time. So until next time, have a good day, have a good night, whatever it is, wherever you're at. Take it easy.